Time. The time proves that we have come a long way to get where we are today. Dayanand Sagar University, with the legacy of 6 decades, had contrived to the achievements today and is throwing light on the way forward. Our visionaries understood the need to learn and know, to do and grow, to twiddle and tweak, creating the best of the thinkers, creators, innovators, and inventors. In fact, we believe in achieving more than ever before, instilling the commitment to strive continuously to serve the national and global needs. There are challenges we can't ignore, but remember, we are of humankind, and every objective is achievable by setting our minds, and Dayanand Sagar molds you to achieve the objectives in an environment that enhances creativity and innovation. If we all embrace the spirit that there really is no limit, if we rise to this occasion and come together across nations, if we integrate and ideate, we can make the future great and live the dream. Our legacy of education takes its root from our founding father, late Sri Dayanand Sagar, a visionary, an educationist, a powerhouse of knowledge and a believer in transforming the world, besides a leader par excellence. The institution has contributed to educating the world for over 60 years, carefully building alumni of over 100,000, including accomplished professionals, sports personalities, celebrities spread across the globe. We stand strong as a top-rated university, having 4 campuses with 350 teaching staff, educating 4,400 students with pride-filled and powerful alumni network across the globe. Dedicated faculty members who work across disciplines, collaborating and lifting us as the top university in the world, empowering the rising generation and nurturing entrepreneurs. Dayanand Sagar University. Live the dream.
It's already late. Where's Arjun?
He's looking for universities, right? Maybe he's held up there.
You look so tense. By the way, did you get to choose the university?
No, I'm unable to find a university that meets my requirements.
Whoa. Meet your requirements? What exactly are you looking for?
I'm looking for a place that gives me an opportunity to grow, to excel, to invent, and to innovate. I want to be a part of an institution that paves my way to discover myself and to witness the world moving forward in technology. I want to go to a place that sets a futuristic pattern of education filled with ideas and radical performances. Basically, I want to live my dream.
Dayanand Sagar University. Live the dream. Time. The time proves that we have come a long way to get where we are today. Dayanand Sagar University, with the legacy of 6 decades, had contrived to the achievements today and is throwing light on the way forward. Our visionaries understood the need to learn and know, to do and grow, to twiddle and tweak, creating the best of the thinkers, creators, innovators, and inventors. In fact, we believe in achieving more than ever before, instilling the commitment to strive continuously to serve the national and global needs. There are challenges we can't ignore, but remember, we are of humankind, and every objective is achievable by setting our minds, and Dayanand Sagar molds you to achieve the objectives in an environment that enhances creativity and innovation. If we all embrace the spirit that there really is no limit, if we rise to this occasion and come together across nations, if we integrate and ideate, we can make the future great and live the dream. Our legacy of education takes its root from our founding father, late Sri Dayanand Sagar, a visionary, an educationist, a powerhouse of knowledge and a believer in transforming the world, besides a leader par excellence. The institution has contributed to educating the world for over 60 years, carefully building alumni of over 100,000, including accomplished professionals, sports personalities, celebrities spread across the globe. We stand strong as a top-rated university, having 4 campuses with 350 teaching staff, educating 4,400 students with pride-filled and powerful alumni network across the globe. Dedicated faculty members who work across disciplines, collaborating and lifting us as the top university in the world, empowering the rising generation and nurturing entrepreneurs. Dayanand Sagar University. Live the dream.
Good morning, Patwardhan sir. This is Damodar from Entupal Technologies. Can you make me the host? Presenter for the
Yes,
session?
yes, yes. Good morning, sir. Good morning.
Yeah, thank you. Sir, shall we get started?
That is what we'll start, Damodar sir.
Yeah, we are ready, sir.
Okay, then I'll introduce you to the participants and then you can start off.
Yeah, yeah,
Okay.
sure.
Okay. Good morning, participants. Welcome to the day 6 of ISEP 2020 PASS, that is the International Skill Enhancement Program 2020 on programming and simulation software. Today we are going to have a session from Ntupel Technologies Private Limited. The resource person is Mr. Damodar MS. It gives me an immense pleasure in introducing him. Damodar is working as a business head at Ntupel Technologies based out in Bangalore, India. He is primarily responsible for design services, consulting, application engineering for customers across India from defense, aerospace, and corporate sector. Prior to this assignment, he was serving IEEE as a full-time employee in a capacity of product manager, new products and initiatives. At IEEE, he was contributing as an industry liaison to semiconductor industry. He was actively involved in IEEE Standards Association activities, supporting System Verilog and UPF work groups. Contributed for the participation of industry leading organizations in evolution of standards in India and Asia Pacific. Actively involved in forming the IEEE standards team for IoT and other emerging technologies. He also supported a new learning initiative from IEEE Blended Learning Program. Received appreciation award from IEEE President for his contribution for proliferation of standards and learning activities. Damodar carries 19 years of industry experience with the core expertise in VLSI and electronic system design, with experience in telecom equipment, medical systems, aerospace, automation, automotive hardware system design. His career spanned across organizations Alcatel Lucent, Bell Labs, Wipro. Also worked with the Xilinx and Mentor Graphics customers. The supported Xilinx University program and Mentor Higher Education program. Throughout his career, he supported educational and competency building activities. He contributed in developing learning solutions in the space of RTL design, verification, time analysis, system design, and many more as a subject matter expert. Received appreciation award for his contribution in competency building initiatives for internal engineering resources at Wipro Technologies. Currently, he is supporting IEEE in educational activities. He is actively assisting the Electronic Sector Skill Council of India in developing national skill qualification framework for engineering job profiles in VLSI domain that include design and verification engineer, system design engineer, and more. Damodar holds Master of Technology in VLSI and Embedded System and Bachelor of Engineering in Electronics and Communication stream. With this, I welcome Damodar and thank you for accepting our invitation, and on the holiday you are delivering this lecture. Thank you and welcome once again, and please take over the session. Damodar?
Yes, sir. Thanks, sir. Thanks for introducing me to the participants. Good morning, all. Before we get started with the things, we request you to follow a few ground rules, okay, for productive interactions, okay, for all the participants. Please keep your mic on mute and turn off your video throughout this session. And if you come across any queries, okay, feel free to use the chat box, okay, to share your questions. And all your queries and questions will be answered in the QA session. So today we are going to be talking about IoT as a technology. Okay, right? Today we no longer call IoT as an emerging technology. Okay, because IoT is among us today, and it's prevalence and its importance is ever growing. Okay, because of the kind of a scenario, unprecedented scenario, which the entire world is going through. So as a result, its adoption probably will keep increasing. Okay, right, in the ongoing scenarios, and the early indicators of those things are already being seen. Okay, right, across the globe more and more. So today in our interaction, or else in this session, we are going to show we are going to present more information on those things also for the benefit of all of you. So before continuing further, okay, right, I would like to provide a brief overview about the organization where I come from. Intupal Technologies, we are a design services and product organization, okay, right, having our core strengths and expertise in the field of VLSI and semiconductor and electronic system design and solutions and RF and antenna design, plus mechanical structures and as well as computational fluid dynamics and finite element analysis. And we also cater to electrical drives and renewable energy systems, okay, a segment also. So, and plus we also work on couple of emerging technologies like 5G and as well as even IoT and plus e-mobility. Okay, in fact, we have a separate division under Entupal known as Entupal e-mobility, which works on e-mobility solutions for our clients. So in all these technology areas, okay, right, we do cater to defense and aerospace customers in India and as well as overseas. And plus, we also cater to the leading technology houses of the globe, plus even mid-market segment, which includes original equipment manufacturers and as well as turnkey solution providers. And plus, we are proud to say that we bring in all that technology transfer to academia community across India through our Entupal Academia Solutions initiative group. So this is briefly about us, and this is the core values on the basis of which Entupal works. Okay, right, with all spheres of of the ecosystem. So these are the major technology domains, okay, where we have our presence. So you name any engineering technology, we have our presence. So if you want to know more about any of the technologies which are being listed here, we urge you to visit our website and you can get more information and you can get in touch with our technical teams and support teams, okay, right, for any kind of further assistance and more information regarding products and solutions what we are offering in these verticals. So these are the bigger business units which constitutes Entupal as an entity. Okay, we have a computer-aided engineering division, which basically works on simulation solutions. And in 2017 and 18 consecutive years, we've been recognized as top 25 simulation solutions providers. Okay, by Outlook CAE. Okay, right, at Asia Pacific level, which we are really proud about. And we also have a products division known as Entupal Products Division, which works on a lot of new products, okay, right, for the R&D customers and as well as for the OEM customers also. And plus, we also work on services solutions for all category of customers of ours. And we also provide learning and development solutions for a wide range of audience, starting from practicing engineers to even up to students level. And our Entupal Academia Solutions initiative is the window through which we do the knowledge share and we do exchange all our solutions and exchange all our learnings, okay, from all these verticals with our academia community across the globe. The major market segments where we operate are aerospace and defense and public sector units, plus automotive majors from India and as well as from overseas. Then we also work with research labs which includes all the CSIR and as well as all the DRDO labs. And then we also provide on-site and online training programs. And market, okay, that is another segment what we operate with. In fact, we carry expertise in our experience in delivering upcoming technology adoption based webinar sessions for the corporate users for our technology partners like ANSYS and as well as Cadence in the last couple of years, wherein we have addressed the engineering community from across the globe, in fact. So this is a bird's eye view about our presence pan-India. So today we are an organization with more than 135 plus employees across India, and we are concentrated in each and every place. So you can definitely reach out to us, okay, at a locality, right, where you can get connected to our representative. So we are proud about our partners, technology partners with whom we are working with, okay, right, which includes all the players who've been listed here. Each one of us, each one of them, they bring in a wide range of proven solutions from their end, and we also bring our expertise in each one of these engineering vertical as an organization. Being simulation solutions from ANSYS, or else test and high performance test and measurement solutions from Anritsu, and the PCB prototyping and as well as PCB fabrication solutions from Vanguard, and VLSI EDA solutions and as well as electronic system simulation solutions from Cadence and Arcad, and PCB prototyping and rapid prototyping solutions from MITS Japan, and additive manufacturing solutions from EOS Germany, and Nanatom, which is more on the material characterization and prototyping solutions, and Niveti Systems, with which we are working on cybersecurity solutions, which is very innovative. And in fact, we have our corporate users who are already working on this particular solution, okay, in the space of cybersecurity with us. And Entupal e-mobility, which is our newest division, okay, which is an extension of Entupal, through which we are offering e-mobility solutions for the startups in India and as well as overseas also. We are also working with leading automotive suppliers, okay, right, on the electrical vehicle technology solutions. And with Semicron, we work on electrical drives for the renewable energy system. And with Excel VLSI, we work on design services and consulting activities, specifically focused towards VLSI segment, okay, right, for the leading semiconductor players in India and as well as overseas. Coming to today's topic of discussion, okay, Internet of Things. So today, when we are talking about IoT, yes, the IoT started its visibility in the market from 2012 and 13. But for your information, Internet of Things as a technology has its roots way back from the years of 2005 and 6. So in fact, during those days, a couple of leading networking and as well as technology houses like Microsoft, Cisco, Juniper, right, and as well as a couple of other leading players like HP, they were very much interested in bringing a solution known as uninterrupted connectivity, which we are today talking about in Internet of Things. So that uninterrupted communication, okay, right, the technology, they named it as unified communication. Even today, if you go to Google search and if you type unified communication, you find the roots of unified communication way back in 2004 and 5. So this technology, which was envisioned by these leading technology players, right, how it was looked at was, for example, if you are making a call, okay, right, when you are at home, probably you may be handling your call over voice over IP from your home. Okay, for example, a internet connectivity may be running from your home, where your call is managed through your voice call is managed through your voice over IP, that is your IP network of your internet at home from your broadband or whatsoever. And the moment you step out of your house and got into your vehicle, okay, right, then the call handover happens from the data network of your home, okay, to the GSM network, which is going to be provided by the GSM player like Airtel or Vodafone or any other player, okay, right? And then the moment you are entering into your office working premises, then again the uninterrupted call transfer should happen from your GSM network to, or else from your CDMA network to your corporate, okay, data network again. So here we were talking about the call transfer from the IP network to GSM network, from GSM network to IP network seamlessly without you having any kind of a difficulty or else any kind of a compromise on your experience, what you see, okay, as an end user in managing your call. So this concept was mooted during those early years of 2000s by these technology players, but somehow the technology evolution during those days, okay, was not really matured enough to embrace these things. And at the same time, the pervasiveness of internet as a technology, or else the spread of internet as a technology, okay, was not that extensive during those days. Those factors really affected the proliferation of this technology further deep into the ground level. So as a result, the unified communication, which was proposed during those days, okay, right, as a technology which is going to be shaping the future of this world, technology world, and as well as common man's life, somehow didn't really took off as expected. So later, after the invention of the Android operating system, okay, by Google in the year 2007 and 8, once again the wings of unified communication started to roll out, and as a result, subsequently many other technology players also joined their hands to bring a shape for uninterrupted connectivity for us. That basically laid the foundation for Internet of Things. Okay, so as a result, the mobility as we started seeing in the later decade of this century basically laid the foundation for the internet proliferation at the grassroots level. So as a result, the technology adoption also started to gain its momentum. So this basically provided a lot of excitement even to the technology companies. So wherein they brought in the different pieces of the technology to bring in a concept known as Internet of Things. So what is this concept of Internet of Things? It is pretty simple. It basically talks about seamless connected world. As you can see here in the examples which are being captured in this slide, whether you talk about wearable technology today, your wearable technology gets connected to your smartphone, and your smartphone gets connected to your cloud, and all the applications which you are using from your smartphone or else from your desktop or else from your laptop, everything gets interlinked, and plus all the information flow seamlessly gets tracked. And if you wish to make that data to the public, okay, right, you can always share that with your community and to the users, okay, whom you want to make this available. And at the same time, lot of critical applications are getting benefited from this technology. For example, healthcare. Today, if somebody wants to have a monitor on the senior citizens at home or else young children at home, okay, with medical assistance running from home, right? They don't need to worry about the scenario today because of the Internet of Things penetration. We can manage that effectively. And coming into smart appliances, today you take your refrigerator or air conditioner or else your automotive. So everything has a smart element, okay, which is embedded in it. So as a result, when it comes to maintaining the temperature ranges of different cabins of your refrigerator, you can manage so, right? And or else it has built-in sensor which adjusts according to the settings what you have done remotely even through internet. So that is a kind of a scenario what IoT is all about. Continuing further, Internet of Things not really talks about only automotive, healthcare, and connectivity alone. There are a lot of applications which look like very half-beat. Okay, for example, L'Oreal, okay, Paris, okay, which is one of the very popular brand in cosmetics world. Okay, right? Even they offer, okay, right, IoT solutions along with their products. Okay, for example, if you buy any products, okay, from L'Oreal Paris, okay, right, they say that, okay, what are the different compositions and everything through which the end users can gain a better user experience. Same thing with right distillery companies like Johnny Walker. For example, today, if you buy a brewery of Johnny Walker, it comes with a RFID, and the moment you scan your brewery, right, then you can actually see that, right, whether the authentication, the date of manufacturing, and everything which is authenticated by Johnny Walker. And plus, it also gives you probably some hundreds of recipes which you can prepare from that brewery. Similarly, Chai Point, okay, right, today it is using IoT technology for the seamless management of the stocks and the inventory across their shops, okay, right. And at the same time, Baskin Robbins is another ice cream parlor chain, okay, right, across the globe, okay, right. They are also offering, okay, right, they are also using IoT technologies for the effective management of their inventory. In fact, this technology adoption which Baskin Robbins did, okay, in 2018 and 19, helped them to reduce, okay, right, their supplies which were getting spoiled because of the power supply failures in the local shops. In fact, they adapted or embraced IoT technology, and as a result, they were able to bring down the wastage of the ice cream stocks in the local shops or endpoints of theirs, okay, right, through effective management of the power backup, okay, right, at each and every outlet of theirs across the global level. And at the same time, okay, this technology is today very pervasive in our home, daily life devices, business and public infrastructure, and healthcare. You name anything today, right, already IoT is there for you. But IoT is not about only the things. IoT is about people connecting to the things. For example, today, when we talk about any individual, all of us, we are surrounded with so many sensors, okay, which we are carrying with us. But like ECG sensor, motion sensor, and lot of other things, okay, right, which we are carrying. And all of that are today seamlessly connected to your smartphone, right? And that smartphone is connected to, right, a data cloud, okay, right, which is through your internet, right? And all that data is getting recorded seamlessly. And today, the moment you turn on your mobile at the beginning of the day, according to your taste, according to your likings, according to the history of your usage, news feeds will come to you. Okay, apps will start giving the data to you. So all of this is happening because the people are connected to the things around them. So it is not about people connected to the things, it is things connected to the things, like connected car, right, or else, right, even fueling stations, okay, right. So as a result, today we are in an era of complex and heterogeneous resources and networks which are seamlessly connected with each other. So in the forthcoming slides, I'm going to be talking about what are the communication technologies which are also in action in this entire hierarchy of connectivity in IoT. Moving further, the underlying current of all these technologies is once again wireless sensor networks, or WSN. So as all of us, we are aware, wireless sensor networks, okay, right, are the legacy technology, which basically laid the foundation for connectivity, right? What we are talking about today, or seamless connectivity, what we are talking about today. So that basically came in, okay, with a concept like several nodes, okay, getting connected to, right, a sync node, and that sync node getting connected to a gateway, and several devices connected to a gateway, and that gateway in turn connected to, right, a core network, okay, through internet, and then the core network getting connected to, right, different services, okay, right, according to the end user requirement. So here the wireless sensor networks, okay, right, which basically the networks typically run with low power devices, right, and plus consists of one or more sensors, could be of different types of sensors and actuators. So this basically was the basic composition for the IoT as a technology in the very, very initial stages. Moving further, how are these networks are changing and how IoT itself is evolving? Okay, right. For your information, even the global bodies of standard defining agencies like IEEE is working towards right, formulating standards for the IoT as a technology. Please be aware that there is no matured and accepted standards, okay, which are readily available to you at this point of time for every application. There are certain standards which are available, but things are evolving. So if things are evolving, even the networking technologies which are basically bringing this seamless connectivity, that is also changing. Then how it is basically changing? We are having a lot of extensions today because there are more and more number of nodes which are part of this connectivity chain, and there are more connections. So obviously, when there are more number of nodes, there are more connections, and as a result, there are new IP network, okay, right, technologies like IPv6 and low 6 GPON, okay, right, and other technologies are in action for the extended extensions of these connections. And plus, anytime, any place or anything is the mantra today where we want to have seamless connectivity. And at the same time, when we are talking about connectivity, it is basically machine to machine also. And IoT basically today has enabled billions of devices which are totally interconnected. And at the same time, the bigger objective or the goal is that everybody is connected. So if you notice today, even in our country, the open internet access or internet access has gone up to the penetration level of even Jilla Panchayat level, and already central government of India is working towards, okay, right, taking it to the grassroots level, even at Gram Panchayat level also. So, so when we are talking about, right, connectivity going to the last mile, so you can imagine we are planning to bring in each and everybody, right, in our ecosystem to be connected to the, right, IoT. Then expansions. So there are a lot of expansions, okay, right, broadband and other technologies which are currently very much in action. Then enhancements like smart networks, data centric and content oriented networking. So these things are in very much in action. Then context aware systems also, where a lot of these systems are autonomous and intelligent embedded also. So these are the things which are becoming more and more pervasive or else more and more evident because the legacy networks are legacy networks, right, are autonomous systems, okay, they were having lot of limitations and lot of limited capabilities, whereas those systems are evolving. Okay. Coming into the future of networks, so we have three different corners which we are trying to meet at any given point of time as far as networks which are evolving. The first one is anytime connection. Second corner is any place connection, and third one is anything connection. So this is basically the framework which is proposed by even ITU, International Telecommunication Union. So on the move, whether you are indoors or outdoors or day and night time, you need to have networks which are going to enable the connectivity for you. And at the same time, any place, whether it is outdoors or indoors or from the PC or away from the PC, then at the same time, anything connection, whether it may be a component to component connection or else human to that equipment connection or else human to human connection or between the machines. So we are talking about such, that's where exactly artificial intelligence and a lot of other technologies are taking a natural extension from the growth of IoT. So if IoT is bringing so much of changes and so many additional extensions, if it is creating, then it is important for us to understand what are the basic building blocks of an IoT and how those basic building blocks are layered or else hierarchically they are present. So the key blocks of an IoT system are sensors and compute blocks and then connect. For example, as you see here, there may be a temperature sensor and that temperature sensor may be giving an electrical signal which is going to an electronic circuit, maybe a display, and then that system is going to get connected to a gateway, and that gateway in turn connected to a cloud, with analytics engine inbuilt in that cloud. So that is a kind of a hierarchical structure what your IoT comprises of at a top level. But the most critical components of an IoT system is sense, compute, and connect. Now, let us try to understand what are the different layers in an IoT system. So in any IoT system which you notice or else which you come across in your day-to-day life, you can evidently notice this thing. The 4 layers of IoT are things, gateway, cloud, and analytics. So let us see that one by one. As you can notice here, whether you take your smartphone or else an automotive or else an agricultural utility vehicle or else automation vehicle, autonomous vehicles. So in all these or else even a medical diagnostic system, all of these are basically things or else all of these are basically equipment today embedded with the ability to not only capture and respond to the inputs and outputs, they are also embedded with sensors, they are also embedded with lot of actuators with some intelligence. So that is the basic difference between the equipments of yesteryear and to the compared to things what we are using in the today's scenario. Simple example is, for example, if we are referring to the automotive sector itself, if we recall ourselves to the scenario of 1960s and 70s, it is just an automotive, but later lot of electronics becoming part of an automotive. So today we are talking about connectivity and even internet access, in an automotive vehicle like MG Hector, which has an internet inside. So as a result, today it is not an equipment or else it is not a utility at all. It is basically a thing. Then that thing, if it is embedded with sensors and actuators and which can transmit and receive data and information, then that basically interacts with your gateway, which is basically a node which enables, which is basically a component which enables all these intelligent systems to talk to the internet or else talk to the central storage, which is cloud. So that unit is nothing but your gateway. Now, once the gateway provides that interface between all these elements and to the cloud, then the cloud will take over. And in the cloud, today you have all your data getting captured through your cloud. And plus, your cloud is not simply a place where you are dumping the information. No, not really. Because, for example, if you take your own apps, what you are using, or else any other gadgets, what you are using today at your home, or else in your workspace, lot of information, what you produce, or else lot of information, what you handle, all of that all that, okay, I'm sorry, there is a little bit of disturbance in my background, sorry. So all of this is today connected to your cloud, but it is not just a space where you are dumping the information or else where you are dumping all the data which you have acquired from the different sources. It also includes a lot of analytics embedded within it. So how effectively that data can be utilized, okay, right, for your subsequent application, one thing, plus whether you can optimize the utilization, and third thing is that whether you can make the entire process more and more economical, power and energy efficient or process efficient. So your analytics today, which is part of your cloud or else an integral component of your IoT, is basically aimed at addressing all these things for you. Now coming into the different layers, okay, we would like to show you what are the different components which already right part of these 4 layers. And as a technology company, we are proud to say that we have our presence in all these 4 layers of IoT as a system. So today, when you are dealing with IoT-based applications or else IoT-based right learning activities at your campus, we feel that it is important for you to know that what are the different components which you are already seeing around you and which layer they basically belong to. That's very, very important for you to know. For example, if you look at layer 1, all the elements that are part of your IoT layer 1 includes sensors, actuators, right, and a lot of other basic building blocks, okay, right, constitutes your layer 1. So an IoT device in this layer 1 is a piece of hardware with a sensor that can transmit the data from one place to another over the internet. And there are 3 main capabilities of a typical IoT device, okay, right, which you essentially notice. Hope I'm audible to all of you. So the 3 main capabilities of a typical, am I audible now?
Damodar sir, you are audible.
Yeah, I'm trying my level best to cut down the noise, okay, which is coming from my surroundings, okay, because there is a lot of noise in the background. So the 3 main capabilities of a typical IoT sensors or devices is they can sense and record the data, first thing. They can perform the light computing for you. Okay, they are no longer just a device or a gadget which basically senses and records the data. They are capable enough to do light computation for you, like doing the analysis of the different parameters which it needs to capture and how much amount of what is the metrics of the data which you want to capture. So basically they are equipped to do a lot of light computation at their end itself. Plus they can connect to a network and communicate that data. So gone are the days where they are passive, okay, right, sense devices or record devices where they used to just sense the data or record the data. Today they are also equipped with, okay, right, network and communicate capability. This is where exactly, in fact, a lot of technology players, okay, they have bounced back into the action. For example, probably 6 to 7 years back, many of them, they have ruled out, okay, right, Intel as a technology giant. But today, if you notice, Intel is back in action thanks to this communication, okay, because lot of sensors and lot of actuators which you use today, they are coming from players like Intel. And what is surprising is that Intel really started focusing more on bringing networking and as well as communication capability to those sensors and actuators. Okay, right? Because Intel learned that they have lost their market race of the node and the processing units to giants like ARM. Okay, right, in that race. So as a result, they started focusing more and more on the network and communication capabilities for the sensors and the actuators. Okay, right, in each and every sphere of application. So that's how Intel is today becoming another strong player just beyond traditional desktop and as well as server market. And examples of IoT devices are like your smart door locks, smart bike locks and trackers and fitness bands, and agriculture moisture sensors and medical sensors for measuring blood glucose levels and more. So today you see many of these things already we have started using in our day-to-day life. So all these devices, what you are seeing and what is being listed here, that constitutes your first layer of IoT. So when you are going to work on these things, my request to all of you is that please be aware about which layer you are talking about and what is the kind of capabilities, your sensors and actuators you are really worried about depending upon your application. Continuing further, the IoT gateways. So as I mentioned earlier, the devices are the things, they basically acquire a lot of data, and plus they also do a small bit of a computation at their end itself, and they have the capability to transmit and receive the data and drive the end terminals for the necessary actions also what you call for. But if they have to do all of that, then they cannot do all those things on their own because their computation capability is very limited. So if you want to enhance their computation capability and their decision making ability, then you need a bigger engine, which can do that. That is what has led to the concept known as gateway, which basically a solution for enabling your communication, and it is basically device to device communication, where it is just beyond device to device communication, it is device to the cloud, so data center. So typically a gateway is a hardware device which houses application software and that performs essential tasks for you because it has a bigger computation capability. At its basic level, the gateway facilitates the connections between the different data sources and the destination. That is the basic job what a gateway is capable of doing. But today, the definition of gateway is not about only connecting different end nodes to the data center or to the cloud. No, not really. Today, your gateway is expected to support multiple connectivity requirements for you. For example, it need not have to be only Wi-Fi or Zigbee or Bluetooth. Even you expect it to support even Ethernet. That's where exactly you are coming across LoRaWAN gateways, right? Where you want your gateway to equip you even to connect the high-end terminal, easily getting connected to your data center with the rest of the devices. It's not that you cannot afford to have a dedicated, connectivity hub, which can take care of your high-end connectivity, right, a router or switch. No, your gateway should be able to manage your router and it should be able to manage the data traffic which is coming from your refrigerator and from your washing machine and from your smartphone, everything. So that is a kind of a gateway capability what today part of your IoT layer 2. So IoT layer 2 essentially talks about gateway. So the moment you talk about gateway, what is that basically comes into your mind? Once again, I would like to bring it to your notice that you might have seen already experienced and guided many of your students for the projects and their other academic research and development activities one thing which I would like to bring it to your notice is that, okay, the Arduinos, what they use basically constitutes the node elements are layer 1 along with the sensors and the actuators. Whereas the high-end processing capability devices such as Raspberry Pi, okay, with a lot of additional accessories, what you are seeing here like ADC, high-speed SD card, right, and display and connectivity cables, okay, all of that constitutes your gateway. So as you can notice here, a Raspberry Pi, right, which is enabled with USB host connector and as well as Ethernet connector, okay, right. So all of this basically brings in a lot of connectivity capabilities for you, and a Raspberry Pi can be a very good example for a gateway. But nevertheless, Raspberry Pi is not the only piece of hardware which can act as a gateway for you. Even LoRaWAN, okay, right, development platforms can also act as a gateway for you. So typically, the gateway, it is enabled with multiple communication protocol support with necessary stack and applications, everything pre-built or readily available. Okay, the only bigger advantage with Raspberry Pi is that the community of Raspberry Pi is quite vibrant, and a lot of open applications is being developed by the community developers and made available at free of charge, okay, right, for somebody to build an application without much effort. For example, if you want to build a solution, okay, for the medical IoT systems, the moment you pick Raspberry Pi, the advantage is that you can pick the IPs, you can pick the pieces of the code, and you can pick the applications and everything, and within no time you can build your system. That's why the Raspberry Pi adoption is so rapid, right, in the world. But nevertheless, it's a community open platform solution. It has its own advantages and disadvantages. Now coming into the cloud, okay, right, after the node and the sensors and actuators and the gateway, the next layer in the IoT is your cloud. The cloud, as all of us we are aware, okay, it's a storage to manage the data pertaining to any application. So today we are not in a scenario that if I need to have infinite storage, then I need to have a complex hardware at my home or else in my office space. No, not really. Today we are not in that era at all, where if your infinite storage requirements to support your applications can come as a service. So the people who brought in those concepts are the three majors, okay, right, who are being listed here. Amazon, okay, right. Amazon is offering their Amazon Web Services, AWS. And Microsoft Azure is another cloud service provider from Microsoft. And then we have even Google Cloud also, through which they also offer cloud solutions. Apart from these three major technology players, you also have a lot of open source cloud solution providers also, like OpenNebula, Zen, Nimbus, and a lot of other players. But what is basically all of them they are doing? They basically enable the cloud storage service for you according to your specification. For example, today you want to have a high-end computing resources to be available to you. For example, if you are working on a machine learning application, or else if you are working on a signal processing application where you are handicapped with a low-end desktop or a laptop at your home, you don't need to worry about that. What you can do is you can buy Microsoft Azure services, cloud services, or else Amazon Web Services or Google Cloud Services, where through your low-end computer you can get connected to a gateway of high computing engine, okay, right, through the cloud services which is going to be coming from any of these players. What is the kind of a services they offer? You can define what is the kind of a computation space you want, computation capability, whether you want. You want 4-core, 8-core, 16-core, 32-core processing unit, you define that. Whether you want to have the primary storage of 16 GB, 32 GB or 64 GB, choose that. Or else whether you want to have a plain vanilla of the computation setup, you define that. Whether you want to have a graphics chipset for the video intensive or else for high resolution video and image processing related application, you choose the graphics right a component which needs to be part of your cloud. And plus, whether you want an analytical engine to be added to that, you define that. So as a result, it is very user specific, right? For example, today, when many of us, we are talking about even enabling a low-end computing setup, okay, for the kids to have uninterrupted learning through online learning. So you don't need to worry about investing, okay, right, a high-end infrastructure at your home. What you can do is, if you have a low-end system at your home, you can still enable all of this with the help of cloud services. Only thing is that depending upon the type of the applications and the type of the connectivity, what you would like to have, you need to choose that, okay, right, what kind of a cloud solution really caters to you. So the good advantage of cloud is that it can be user specific and it can be customizable so that it can fit into your budget. And at the same time, it is very secure because AWS or Microsoft Azure or Google Cloud has proven their secure cloud services, okay, for their customers across the globe. And at the same time, these solutions are quite highly reliable also. So as a result, today, when we are in the process of setting up of an IoT system for a specific application, the good thing is that we don't need to worry about setting up of huge hardware, okay, right, for our applications. No, not really needed. Then what is basically the reference architecture of an IoT looks like at a very, very top level. Okay, this is how it looks. So it has devices which consists of sensors and actuators. Then it has a gateway. Then the gateway which connects to the cloud of the IoT subsystem. And then you also have your analytics engine, which in turn controlling your application. So this is the top level reference architecture of the IoT systems, what you are seeing today, right, in our day-to-day life. Now, the more important thing is that what kind of a communication technologies are running in these IoT systems. It is very important for you to know that, okay, right, what communication technologies we are talking about, okay, right? And this is where exactly I would urge with all the faculty is that when your students are working on the IoT, please ensure that, right, they are really aware about what communication technologies which they are talking about, first thing. Second thing is that, right, when they are talking about a specific communication technology, whether it is Bluetooth, Zigbee, or any other, okay, technology which has been listed over here, do they really understand all the layers of that communication stack, starting from the the physical layer to the application layer? Do they really understand all the layers, okay, right, in that communication technology? That's very, very important. And the next question is that where exactly they are working, okay? Today, when any one of us, we build a solution, one thing which I can assure all of you is that we may not be working on all the layers of the IoT ourselves, and at the same time, we may not be working on all the communication technology layers ourselves, because it is highly impossible, and unless and until somebody really spends about 15 to 20 years of their experience on these things, right, only then we can call them as IoT architect, right? Otherwise, any engineer, okay, who has a basic knowledge about all these 4 layers with any given communication technologies which are part of the IoT system, the industry calls them as only IoT analysts, right? So hence, I would urge with all the faculty team members who are part of this session today that please identify, right, what is that work which your students are doing, so that you can really guide them and mentor them for widening their horizons, okay, on which they are currently working with. Now, the lowest layer, okay, right, starts with your power line and Ethernet, okay, right, where the communication technologies like PAN, okay, personal area network, comes into picture, which belongs to the standard IEEE 802.15, okay, right, as all of you are aware. Once if you move a little bit higher, okay, comes your LAN, okay, right, which is IEEE 802.11, okay, right, and then if you move little bit higher, then you enter into your MAN, okay, which is IEEE 802.16, and if you move further up, then comes IEEE 802.2.0, that is WAN, and above further, okay, you have your right NFS and LoWPAN, okay, right, and IPv6, okay, right, and then Zigbee, right, and UWB and Bluetooth and other technologies, okay, through all these systems what you see, right, and then beyond that comes your mobility, okay, where Wi-Fi comes into picture, and beyond that comes your GSM, okay, right, which includes license-free spectrum. Remember, there is something like license-free spectrum also, which is used by amateur, okay, right, hobbyists, okay, which is free to use spectrum of the license for the communication. Then you have your WiMAX, and then you have your GSM technologies like 2G, 3G, 4G, and now effectively we are just on the entry of 5G technology. Then you also have your LTE Advanced, which is your 5G, and then beyond you also have your satellite communication. So this is how incrementally the communication technologies are, right, being part of your IoT system, starting from a home to, right, a industry enterprise, and industry enterprise to, right, across the global communication network. So this is how IoT is very much part of your entire, these are the communication technologies which are part of your IoT system today. Now, so at this point, okay, what we would like to emphasize is that, okay, right, in order to summarize things very quickly, please be aware that IoT technology has 4 layers, right? Your devices, right, and your gateway, and your cloud, and your analytics. Now, within these 4 layers, okay, there are different communication technologies, right, which are in action. So these are the communication technologies which are in action. So now we would like to take you through a small demonstration which basically provides the details of all these 4 layers, okay, for you, so that you can clearly understand that, okay, right, which layer you are really focused upon, okay, right. So in order to run through that, okay, I am inviting my colleague, Mr. Arvind. Arvind is our design engineer for the web development applications, and Arvind carries 4+ years of experience in web technologies, and he is also a strong resource on IoT technologies from NTUPL. So with that brief introduction, okay, right, I request Arvind to take over the proceedings for the day. Arvind?
Yes, sir. Thank you, sir.
Yeah.
Prasant, sir, can you make me present, sir?
Yeah.
Yes, I will. Yes, sir. Is it
Just
working?
a minute.
Yes, sir, it is working. Share content, right?
Yeah, I hope you can share now. Can you check?
Yes, sir. But here it's showing only sharing the particular screen.
Yeah, you can share that particular screen, okay, if you want to share at any given time.
Sure, sir. Is my screen visible?
Yes, sir.
Thank you, sir. So, good morning, everyone. So, right now, what we are going to see is a small demonstration of the complete 4 layers of the IoT. I'll show you the demonstration. Due to this quarantine, we don't have any real-time hardware setup, but I'll show you the photo photograph which we have taken earlier. So we will show the weather station projects. So weather station is nothing but we are just collection of sensors that record weather related data. Data which is like temperature, air quality, humidity, wind direction, etc. So these recorded data are sent to the central hub for processing and monitoring further actions. Then central hub collects all the data from the sensors through the gateway. So then the hub generated weather-related reports by using the by using the data which is collected from the multiple stations. Then by using those data, we can just forecast. We can do the weather forecast. Now, the setup what we are going to do. So we need a small basic hardware, just like a breadboard, and then a node MCU, at DHT11 sensor, LDR, and 2 kilo ohm resistor, 10 kilo ohm resistor, few jumper wires, and USB cable. And node MCU, which is nothing but a full-fledged microcontroller, which has an inbuilt Wi-Fi with itself. By using node MCU without any additional hardware, we can directly connect it to the gateway. So whatever data it collects, we can directly send it to the gateway, or we can directly send it to the cloud. And in this example, what we are going to see is a ThinkSpeak cloud. It is an open source cloud platform, and this service, this ThinkSpeak, allows to receive data from the multiple sensors. So you can just assume this as a sensors. We can receive data from multiple sensors, and we are storing into the ThinkSpeak cloud itself. After the storing, we are visualizing. We are doing some analysis based on the data what we have captured from the sensors, which we have implemented. And this is the hardware connection what we have done earlier. So you can see we placed the node MCU in a breadboard, and this node MCU is connected with our PC or laptop, and we are making the connection for the LDR to identify the light intensity of the room, and then we are connecting the DHT11 sensor, which calculates the humidity and temperature around the room. And then what here I have just kept a small LED, which I'll show you when I'm explaining you into the code. From this setup, what I have done is, if the temperature is below 25 degrees, so I'm enabling the LED, which means I'm just making the LED to on. In this case, we did with LED, so you can assume that if temperature is less than 25 degrees, we can switch on the AC. So that's how it works. So let me review the code. So hope you have understand the connections what we are doing this setup. So let me review the code and ThinkSpeak cloud. So to program the node MCU, we are using Arduino IDE. So you can see these are the header files what including Arduino ESP8266, which is nothing but a node MCU, and we are including header files for DHT11 sensor as well, and we are defining a variable.
Excuse me,
we are defining.
Excuse me.
Yes.
Prashant here. Can you increase the font size?
Okay, 1 second. Is it okay?
Yeah, now it's better. Thank you.
Okay. So these are the header files for Arduino and Node MCU, and this is for we are including library files for DHT11 sensor, and we are defining, it's like a constant variable. We are defining pin number 4 for DHT pin, and DHT type, we just made it as a DHT11 sensor because DHT itself, there are different sensors is available. We are using here DHT11, And when the program runs, so it will start from the setup file, whatever the Arduino program runs. So initially we are just beginning the DHT sensor, and we are writing the serial port on this particular port number, so that we can see the data which is captured from the DHT11 sensor. We will be able to see in the serial monitor. And this println, it's nothing but just we are just giving a blank line space. This is like same C like quotes, C the same quotes. Here we are just waiting. We are checking whether we are receiving it data from DHT11 or not. So until till then we are just waiting. So once we receive data, it goes further. And as I mentioned earlier, the node MCU itself has an inbuilt Wi-Fi. So here, to connect that particular node MCU into the router what we have, so we need to provide the SSID here and the Wi-Fi password here. So then, once we upload the code, it will try to connect the node MCU will try to connect to this particular Wi-Fi ID what we had given. And in loop function, till till the moment you disconnect the power, so the loop function will keep on executing. So first, it will check whether the Wi-Fi is connected or not. If Wi-Fi is connected, then we are initializing a variable H, which is nothing but a humidity, and we are reading data from the DHT11 sensor, and we are storing it into the variable called H. Same like we are reading the temperature value and storing it into T. And we are just checking whether it has original value or null value or blank something. So if that is null or some unidentified variable, so it won't execute. It will execute fail to read from DHT sensor. So if we are getting write data from the DHT sensor, the code will go further, and we are initializing the HTTP client. By using this HTTP client, so we can transfer the data what we are receiving from the DHT11 sensor to the cloud setup. And here I'm just printing as HTTP is begin, and then you can see here this is the URL where we need to send the data, which is nothing but a cloud URL. So this is the URL we need to send all this data. The first one is LDR value, and then temperature value, and this is humidity value. I'll come back to you this line. So we are printing that value here. We are sending the value whatever we are capturing, LDR, temperature, and humidity. We are sending it to the cloud server. So after that, we are printing in our console itself. Then once we send the data, we are checking whether the data has been sent into the cloud or not. If it is sent, we will be getting a response code which is 200 in the sense which is like response as successful. And we are checking the error code here. If it is not, we are just repeating the same process in the next time, because this entire part is inside the loop function, so it will execute every 15 seconds. So this HTTP code response gets error, which means the data is not sent to the cloud. We will show an error message called get failed. So that's all the entire program is about. So now we have seen the hardware connection and the program. So let me tell you, show you an example of the ThinkSpeak cloud. You can just visit thingspeak.com. You need to create an account first. So then just go to channels, my channels, to create a cloud setup for the demonstration what we have seen now. In my channel, we need to create a new channel. since we are using a free version, you will be able to create only 4 channels. So I'm creating a new channel called weather station, and description is just weather station. And if you remember in code, we have 3 fields. One is LDR value and temperature and then humidity. So we need to enable 3 fields. Here I am giving temperature. The second value is humidity. The third value is light. Then I'm just saving my channel. So these are the options. If we want, we can make it. We can include with our GitHub page. So that's all. Now we have created a channel. So here, if the coding is everything is 1 second. So once we create a channel, we need to just click on the API keys, and if you scroll down, you can see this is an right channel API request. So I have created the hardware setup separately and the cloud is separately. But how do we connect the hardware? How can we tell the hardware to reach out a particular cloud server? So that's what this API key comes in a part. We need to copy this entire line and we will paste in here. That's what I did earlier. Now, so what will happen is when this NodeMCU device try to connect this ThinkSpeak cloud, and it will identify the particular cloud application by using this API key. If you see, this is my API key, what I have created here. So I need to replace with this, and this is like this is what refers to my application of my channel, this weather station, and I have 3 fields, which is a temperature, humidity, and light. Same like here also, I am creating field 1 is analog. Actually, I need to move this light is first, and then temperature, and then humidity. Here I just made a mistake. So first field, which is for analog value, which is LDR value, and then second field for temperature value, and third field for the humidity value. So once we copy the API key from here, ThinkSpeak Cloud Server, and I'm pasting everything here. Once my code is ready, I'm going to upload it into the NodeMCU device. So once it is done, this server will start receiving a data. So right now, we don't have any hardware setup now due to this runtime, but I'll show you an example what we have done earlier. So you can see this here. We have got around 377 entries of light, temperature, and humidity. So these are the values of the light LDR what we have set up in our hardware, and this is the temperature which is generated by our DHT11 sensor and humidity also. So this is how it will looks once the hardware which is sending data to the cloud server successfully. And after this, to verify that, we can verify this by using our serial monitor. So as we mentioned in our code, we mentioned get, begin, and the temperature value, humidity value, and all. Okay, so this is the serial monitor, and to open a serial monitor in our Arduino IDE, so this is the serial monitor option. Right now it is not opening because the port is, I haven't connected any hardware with my system. So this is the image of serial monitor output. And once the data is captured, as we mentioned here, then we can do an analysis, like MATLAB analysis. So I'll just show you how can we do that. Right now I don't have any data in this channel. So I'll show you the small steps to do an analysis and visualizations. So you can try with your data and I'm just selecting option and I'm creating it. So the MATLAB code will get generated automatically. So then we need to change the channel ID. So if you see the right side, so here we have our channel ID. The channel what we have created is weather station. So this is our channel ID. We need to put this channel ID here, and then humidity field, temperature field. According to the field number, we need to change the field number and then read API also. So this channel I want read API. I'm copying it here and just pasting here. And once I made these configurations into the code, then I save and run. Whatever the options we have chosen in the previous steps, it will get analyze the data what it is generated from the real-time setup. And then let me show some visualization. So that is one part analysis, and let me show you the MATLAB visualizations. So you can click apps, all apps, and then MATLAB visualization. So I'm creating a new visualization here. I'm just doing histogram to understand variation data. So I'm creating a visualization. So as I mentioned earlier, we need to change the channel ID, read API, and the fields, but we want to visualize. So right now we won't get any proper output from this setup, but I'll show you an image what we have done earlier. So you can see here, once you created a visualization, it will appear into the dashboard itself. So you can see here, this is the pressure data, and this is the humidity values, and you can see here is the temperature value. So this is the output of the visualization what we have done through the ThinkSpeak Cloud MATLAB visualization option. So let's move to data analytics in IoT. Analytics, which is nothing but the science of analyzing raw data in order to make conclusions about the data. Because the devices, whatever they are set up in the field, which is keep on generating a data, it is sending it to the cloud. But after the data capturing, what is the use of the data? We need to do some analysis on the data, and then we need to identify some meaningful insights from the data. So that's what we will be able to do some business use cases. And why analytics is important in the sense, all the data, all of the nodes, which is nothing but the hardware components like sensors and actuators, which is generating a data every seconds or every 5 minutes kind of a thing. So these data, from this data, we need to extract a meaningful insights, which is very important for business. And a lot of data which is generated from the devices, the first thing to understand about the analytics in IoT is that is involves in data sets generated by the sensors, and the data which we are generating and we are storing into the cloud, and we are doing some analysis to make the efficiency of the business. And in analytics, there are various types of analytics. I'll just get back to you that in the next slide. So, data science in IoT analytics. So the word data science have taken the business world today. Nowadays, improving business productivity and performance, which is greatly depends on the collection and analyzing the data which generated from the hardware devices. So data collected through IoT devices, which is analyzed and using the different technical to compare the data in a traditional methods. But data scientists are using various kinds of algorithms and techniques, end-to-end methodologies to retrieve and meaningful insights from the data which is generated from the hardware devices. So there are mainly four types of there's five types of main analytics mainly used to in any kind of analytics and data science algorithms. So first one is descriptive analytics, and descriptive, which is nothing but just used to mainly identify what is happening in my business. For example, by having an historical data, we are doing some analysis, we are doing some descriptive analysis to understand what has happened for last year. That is descriptive analytics. When it comes to diagnostic analytics, we are analyzing why is it happened. For example, the business for last 1 year business is low. We are analyzing why the business got very less. And in predictive analysis, we are predicting for the future. For example, we have a data for last 5 years. We are analyzing the business levels for last 5 years in each year level, and we are predicting what is the business I am going to achieve for the next year, means upcoming year. So that the prediction will be identified by using the predictive analysis. And the last one is the prescriptive analytics. So if we predict what I'm, for example, if I'm going to sell 100 products next year, by that I identified by using the predictive analytics. But from the prescriptive, how can I make it happen? So that's what comes into the prescriptive analytics. How am I going to sell 100 products? So that is the point of prescriptive analytics. And data science, just looking at the problem of IoT analytics from an end-to-end methodologies by using multiple algorithms and techniques. So it helps to handle any kind of analytics scenario when it comes to an IoT data. For example, let's take an example of transportation. We are shipping any kind of device, any kind of parcel, one place to another place. So we can track the real-time situation where the particular parcel is arrived. So when I'll be getting delivered. So that real-time data, we will be able to notice, we will be able to track it when we are implementing an IoT. Next. So next one is machine learning. So why machine learning is important? So first, so what is machine learning? Machine learning is a field of computer science that gives computers the ability to learn with data without being explicitly programmed. So which is nothing but we are training the machine, and the ability of machines predict the outcomes without any human intervention. Machine learning it's about creating and implementing algorithms that let machines to receive the data from the devices or from the data cloud server, and by using the machine learning algorithms, use it to make a predictions depends on the algorithms what we are seeing in the earlier session. Machine learning provides the list of statistical tools and to explore and analyze the data. So there are three main approaches which is used for using machine learning. One is supervised, and second one is unsupervised, third one is reinforcement. And the first one is supervised, which is nothing but we are creating For example, let's take an example of temperature and humidity data. So whatever the fields available, it has a label called temperature and humidity. So when we are analyzing data with labeled data, so that comes into the supervised machine learning techniques. And the second one is unsupervised technique. So when we don't have any labeled data, which means unsupervised will be used for the non-labeled data. The method what we are using here is the clustering method. We are grouping the data what we have collected into the clusters, and then reinforcement learning. So it is reinforcement techniques we can use with some part of data will be labeled one and some part of data which doesn't contain any labels. So in that cases, we'll be using reinforcement algorithm techniques. And applications of machine learning, in a simple example, you will be getting a lot of spam emails. This machine learning algorithm, we can teach the algorithm by using you have win this much cash and amount. So we will put the algorithm from the specific email ID or the specific keywords. So whenever you are receiving an email into your inbox, the algorithm checks the entire email, and if it has any keyword which we put it in the development process for like win cash prizes like that, so it will check entire email what you are receiving, and if the email matches with the certain criteria what we have, it will move into the spam folder. So this is an automated process which machine keep on learning itself. And then the recommendation systems. So you might have seen from Facebook or LinkedIn some recommendation, which is the friend recommendations, the connection recommendations. So that recommendation systems, it is showing you based on the list of friends you have, list of connections you have, or if you are working in the same organization, so it will recommend other people who is working on the same organization. So that's what the machine learning algorithms working as in a recommendation systems. And in artificial intelligence, so AI, which is nothing but we are just simulating the human intelligence in machines. So that are programmed to think like humans. For example, I'll tell you one example. For when we are implementing a small machine learning algorithm, let's consider a machine learning algorithm which I'm teaching the colors to identify the algorithm which color it is. So I wrote an algorithm. I'm teaching a machine. I'm showing the picture of yellow color. I'm teaching them it is an yellow color, and then this is red color. This is green. So once if I have 100% of data, I'll teach the algorithm with 80% of data. So once I teach all the 80% of data by showing in images or any other pictures like that, then with the 20% what I have, I will do testing whether my algorithm what I have written which produce the right output or not. So once it is tested, I will be able to identify if I show yellow color in my front of camera, my algorithm should get a result. It should say color is yellow. So like that. So I will be doing a testing multiple times. So when I'm implementing this algorithm in a real time, so that algorithm itself, it have a knowledge about which is yellow, which is red, which is blue. So that is the small basic example of machine learning. And when it comes to artificial intelligence, okay. So when it comes to artificial intelligence, when we are using for IoT, artificial intelligence, is why we are using AI in IoT. So if you see, according to the Business Insider, there will be more than 64 billion devices 64 billion IoT devices by 2025, which means right now I think we have 2017, according to 2017, we have around 7 to 8 billion devices only. But by 2025, we are expecting to grow up the number of IoT devices. So just think of it, if all the 64 billion IoT devices keep on getting generated the data, and which is keep on storing into our clouds overall. But by using this all the data which is generated by the devices that we are storing to the cloud, we are doing some analysis on the data what we have stored into the cloud. Every time we cannot process the data by manually. We need to do some automation for that. So that's where the artificial intelligence comes into the picture. So then internet which collects the data and storing it hardware collects the data and storing it into the cloud server, and artificial intelligence algorithms which refers some data, and we can do some backend processing, which is nothing but what I have shown in an example. If my temperature is less than 25, sorry, if my temperature is greater than 25, I am switching on the AC. So like that, in artificial intelligence algorithms, if we can write an algorithm to monitor the data which is received from the IoT hardware devices, and by using the real-time monitor, we can do some analysis and we can produce the results, or else we can immediately communicate to the end user or the management team if something is happened, something wrong has happened with the field, or any fire happens, data is getting corrupted. Like that, we can immediately intimate to the concerned persons. So Internet of Things algorithms that convert the data into useful, actionable results, so that can be implemented in IoT devices. So, for example, in my home, I have an AC. I have a Day6 sensor in my room. Okay, so AC also. I can do the same setup in my room. If the temperature is getting high, I can switch on the AC automatically, and also I can do control with my refrigerator cooling level with the same temperature level which is outside of the refrigerator. So these are the applications for the complete artificial IoT and artificial intelligence, drones and smart cities, smart retailing. So this is the complete application. For example, let's take a smart retailing application. If we are going to supermarket, we are purchasing some items, and in the supermarket owner, they doesn't have to maintain whether this particular product is available or not. So once if the product is less than 5, the order will take immediately to the respective vendors. So before it goes 0, the supermarket owner will receive a product from the vendor. So even the customer also will be satisfying with their buying the products what they want. So in such cases, the AI algorithms will be really useful in IoT technologies. So with this, I will hand over to Danu sir.
Yeah. Thanks, Arvind, for running through the thing, okay, for our participants. So that is basically a small application which we wanted to showcase, okay, for all of you. Okay, in fact, because of the ongoing restrictions for the last 3+ months, okay, right? So every one of us, we are also stuck like most of you, and hence we were able to show the glimpses of how the entire chain of the 4 layers, okay, right, really goes in an IoT system, okay, through this demonstration for you. So before we open up the session for the question answers, okay, right, I would like to take you up through some applications, okay, right, which where already you see the use of IoT in action. So let us just share. Uh, yeah, Arvind, can you make me the presenter, please? Yeah, thank you. So I have interesting. We have created a basically a catalog which basically lists down 101 applications where IoT is already in action today. Okay, so maybe a good reference for many of you to know that okay how IoT is in action for you. So let me show that very quickly so that then we can open up the Okay, so here, okay, right, this is one of the, this is the cookbook, okay, which I was referring to, okay, which has been created by us in association with our partner Jigsaw Academy. So here, I was talking about different applications where IoT in action. Okay, here we have 101 applications where IoT is in action. The first one is Abaco ice creams, okay, right, where the traditional challenge what Abaco as an ice cream parlor, what they were facing is up to 25% of the ice creams in the company's inventory was getting melted and being wasted. And the root cause for all of this problem was the poor power backup management in the local outlets. For example, I am in a locality within Bangalore where there is a Abaco outlet, and if the power backup of that local store, if it is bad, then what generally used to happen is that Abaco inventory used to go waste, okay, because of poor power backup where ice creams used to get melted and not being productive for the sales. Okay, so Abaco interestingly came up with right the usage of IoT technology to solve this problem, and in fact. Two of our Indian companies only based out of Bangalore was involved in solving this problem for them. What they did is, okay, they created an application where the moment the power goes down in the local shop, within 5 minutes, okay, right, within 2 minutes, okay, it triggers an alarm through that application to the local store in charge. And if the store in charge don't act upon the power backup and if the power is not restored, then within next 15 minutes it goes to the area manager, and within next 15 minutes if there is no action is taken, then it goes to the zonal manager, and within half an hour if there is no action is being taken, then immediately it goes to the right head of the organization at the country level. So as a result, the sensitiveness on restoring the power and ensuring that the inventory is kept safe, okay, due to the power failures are also becoming being effectively managed by Abaco outlets. So as a result, they were able to bring down up to 25% of their ice creams which were getting wasted to nearly about 2% today. So this is one classic application. In fact, one more application which I would like to show is I hope by now, okay, many of you might be aware about this application, Philips Hue, where you buy LED light to your home lighting system, where the hue of, that means the color composition of that light you can change, okay, according to your requirement. And plus, the good thing is that today it can be integrated with Amazon Echo and as well as Google Home. That is another capability, in fact. So this also uses very much your IoT application. And this is another from our own backyard, okay, right, Chai Point, okay, right. Lack of a streamlined system for standardization for the productization of the tea beverages. Because, for example, this is basically about supply chain management and the role of IoT, okay, in fact, where, for example, in a specific outlet, if it is a specific variety of the tea is being sold at a higher level, for example, it may be a ginger tea or masala tea or whatsoever, then it is important for the tea selling franchisee to ensure that the ingredients are kept in ample number or else in ample quantity to ensure that they can serve that. Okay, so what they have done is today Chai Point, they have tagged that to the local franchisee and plus as well as the outlets wherever they have set up in the corporate establishments and in campuses, okay, right, even academic campuses. What they have done is they have tagged into an IoT application where the moment the commodities or the inventory supplies goes to a level below the prerequisite level, immediately it alerts the local franchisee to ensure that the supplies are kept in station. So this basically serves two things. One is good user experience, okay, right, for the buyers and the users. Second thing is that no loss of business, okay, right, for that franchisee and as well as Chai Point as a whole. And at the same time, right, ensuring that, okay, there is an effective supply chain management end to end, okay, right, so that, for example, if there is a specific commodity of the users are heavy in number in a particular locality or else in a particular franchisee where this setup is running, right, they can effectively manage. After seeing the success of this application implementation by Chai Point, in fact, Cafe Coffee Day also started working on it, but they are yet to release their full-fledged product on this. And once again, the good point is that both the solutions are homegrown and developed by our own startup companies in Bangalore. And another application which I would like to share with all of you is that Honeywell, okay, right? So which basically has brought in a one-stop shop for all your home surveillance and security applications, okay, from its end. So here it has a lot of powerful capabilities, everything integrated into one product. And good thing is that even it can talk to Amazon Alexa, okay, right, for a lot of things, okay, right? So like this, there are n number of applications which I can run you through, okay, right? So in fact, interestingly, I also have one application where Government of India, okay, yeah, has also deployed, okay, for your information, 36 monitoring stations across 2005 kilometers, a stretch of Ganga River, okay, right, which is spread across 11 states, okay, right, where they are collecting the live updates of the water condition. And this is then used to enforce the appropriate environmental policies to eventually to help, clean maintenance of River Ganga, in fact. So, in fact, now after the initial success of this initiative, now Government of India is planning to implement this across the river basins of other major rivers also to ensure that the water is managed, the water resources across our country are managed very effectively. So, so with this note, right, there are a lot of applications today already running with the IoT applications, okay, for you and me. So what is exactly, right, from here we go, or else your students can go. So in that direction, for your information, okay, right, we have a couple of solutions from N-Tuple which we are offering. So one is we have a comprehensive development platforms on IoT. The uniqueness of our IoT solutions is that we cover all the 4 layers of IoT for you, starting from set of sensors and actuators and node MCUs to gateway, and plus even the cloud solutions and algorithms. See, basically the uniqueness of our solutions is that we would like to understand what type of a lab setup which you want to do, whether it is for the basic learning purposes or else domain specific learning or else advanced learning. So accordingly, we have the capabilities to enrich your labs so that it can cater to your applications or else it can cater to the learning activities what you want to drive or else even domain specific research activities. And at the same time, even we have IoT based solutions on machine learning and AI. And once again, in machine learning and AI, we are giving local data center based solutions and as well as even cloud based solutions also. For example, if you want to keep your costs low and at the same time ensure that you are free from maintenance challenges, no issues, okay, right, we are here to help you, where we not only help you to set up your IoT lab, we also bring in, okay, right, machine learning systems okay, to your campus, okay, right, with our technology partners like AWS and as well as Microsoft Azure and lot of other partners with whom we are working today, where depending upon the specific segment of the research work which your R&D teams are working across the departments like computer science, information science, circuit engineering branches, and even mechanical engineering, where if you're working on a specific application, okay, right, as a group, okay, right, we really help you, okay, in that direction to build machine learning and AI solutions based setups, okay, in your campus. So that is on the products and the solutions what we are capable of. Coming into the training programs, we have programs of 1 week duration, and we also have online and classroom internship programs on IoT and as well as data sciences, IoT and analytics, and IoT and machine learning, and IoT and artificial intelligence. So you can pick and choose the models what you would like to deploy for your students. And the beautiful aspect of our programs is that it has both classroom and as well as online without compromise on the user experience. Okay, we have built-in assignments and case studies where students can really run through the thing. Yes, sir. Yes.
Are you sharing any screen? Because we are seeing only the blank screen here.
Oh, is that so? Okay, I'm
Yeah.
sorry. Okay, let me just check, sir. Is it working, sir, now?
Yes, yes, yes. Thank you.
Okay. Yeah. So we also have a full stack IoT program, okay, which is basically aimed at building end-to-end competency and making the engineers ready for the job profiles in the industry, like IoT analyst, okay, right, IoT application developer, or else IoT data analyst, okay, right. So these are the kind of a job profiles which are very much available in the IT sector, and as well as even in the product organizations across India. Okay, in fact, we are proud to say that more than 19,000 working professionals across India has already taken up our IoT full stack program, and organizations like even Accenture and as well as Infosys and other organizations, okay, even IBM, okay, right, they prefer engineers who have completed IoT full stack certification, okay, by us, okay, right, in their recruitment process. So those programs are very much available. If you want to know the details of that, you can please visit our website, okay, for more information. So these are other technology verticals where we are offering solutions, okay, on the webinars and trainings during this hour of crisis. Okay, so if you want to know more about any of these things, my request to you is that please visit our website. Okay, right, we are happy to assist you. And we are offering different learning series programs and as well as online internship programs during this hour of crisis. Okay, right, for the benefit of working professionals and as well as even researchers, faculty, and as well as students. Please feel free to visit our website, and you can contact our academic relationship manager also in your region, so that who can help you out. In that direction, if you want to reach out to our team, you can drop a mail to us at, if it is anything to do with product and solutions, you can drop a mail to us at ask@ntupel.com or info@ntupel.com. If you are looking for any specific support on the training and learning and development activities which you would like to drive in association with our team, then you can write a mail to us at training@ntupel.com. So with that note, right, we thank Dayanand Sagar University and Dr. Patwardhan sir and his team for giving us this opportunity to come and share our experiences and the technology on which we are working, okay, right with all of you. Thank you. So now the session is very much open for the participants to share their questions. So we also have, okay, some questions. Nilgar sir, good to see you, okay, on this forum. So any questions, please, you can share it on the chat box, okay, right? Happy to assist you, sir. One question is from Professor Hiremat. Okay, AI and ML are programming methods. So how it is linked to IoT? Sir, as Arvind showed, okay, right, in the presentation, okay, or else even through the small application which we have ran through, it is basically we are talking about the algorithms for a specific application. For example, it may be about analyzing the data pattern, okay, right? How is the, for example, this is one scenario which is already in action. If in case, if you see the machinery in a factory, like BHEL Jamshedpur, okay, right, or steel factory in Jamshedpur, already this has been implemented, where there are some sensors which are connected to the machinery which are running, and those sensors will be continuously monitoring the wear and tear, okay, which will be subjected to the parts of those machineries, and as a result, they can predict the lifespan and the service and repair and maintenance of that engine, of that component in a proper advanced window period. That's one thing. But now, in order to do that, information from the sensors may run into the node and the gateway and into the cloud. But that data simply sitting in the cloud doesn't mean anything, because meaningful information and meaningful communication has to be derived out of that, and it should be sent to the right appropriate action. So that is where exactly artificial intelligence is coming into picture, and as well as machine learning is coming into picture. Yes, both of them are heavily dependent upon the programming methods, as you are rightly pointed out. But one strong point which we would like to emphasize to all of you is that the way industry sees IoT is that it is 4 connected layers. It is not that hardware abstraction layer and the connectivity layer are one component, and then the cloud and the analytics engine and machine learning engine. No, not really. All of them are totally one integrated system. So hence, yes, if somebody is working at the hardware abstraction layer of an IoT, the competency which is expected for them is different. Whereas somebody who is working at the analytics part of it and machine learning algorithm development point of view, then the competency which is expected from them is completely different. So as a result, when our engineering graduates, okay, in the campuses, when they want to focus upon their career, being in the industry for the last 2 decades, sir, okay, my input is that it is good that they should learn things end to end, because a IT graduate cannot say that no, I don't have any kind of a interest in the hardware. He cannot say so, because he is part of the system today. And at the same time, our circuit engineering branch engineering students, they cannot say that no, I don't understand how the scripting and how the algorithm development and those things work, because the knowledge programming is something which is very much required in every other job role today, whether it is even a embedded application development engineer, or else even embedded hardware engineer, or even VLSI engineer. Basic programming is something which is expected from everybody. And the good thing is that today, if you take HTML scripting or Python scripting or any other scripting concepts, they are very much like a plain vanilla English language, not too much loaded with syntax and everything. So easily overnight they can pick up. But at the same time, I would like to emphasize another fact is that just by merely saying that I know Python scripting, that doesn't mean anything, because if they don't know where that scripting is used, and if they have worked out on a couple of projects using those scriptings, that basically gives a difference for them to the rest of the crowd. So that is very, very important, sir. Another participant, they have a question. I read in many papers that by using AI like ANN, artificial neural network, that results are improved. How is this relevant? Couple of applications which we have showcased in this interaction. You might have noticed that there are a couple of applications where there are some intelligent systems which are part of the node and MCUs. Remember, when I say node and MCU, which is basically a microcontroller unit or else basic microcontroller unit which is connected with some sensors and actuators, right? Today, gone are the days where your node MCUs, okay, right? They are simply capturing the data or acquiring the data. No, not really. They can actually do a lot of actions, okay, right, or else a lot of response things from their end only. Now the question is that if they have to take the appropriate action, what is that appropriate action? Okay, for example, if the temperature of room, okay, which has been remotely set for 25 degrees. Now you want that temperature, okay, right? For example, if it is getting rainy and it is getting gloomy and the external ambient temperature is coming down all of a sudden to 20 degrees, whereas your room temperature is 24 degrees, then in that case you want to increase the temperature for a better comfort. Then today in Lloyd air conditioners, already such type of sensors are there. So basically there you see a artificial neural network already in action. So as a result, and at the same time, Port is already using, okay, right, some robotics robots, okay, to manage patient management in this COVID scenario, where the robo, okay, basically, right, uses, okay, the artificial neural network, okay, right, applications. I mean, it is built on ANN concept. So, and in fact, one institution, Ebenezer, okay, right, in Bangalore, for your information, has already deployed, okay, right, systems where through online learning, the robo, okay, right, can monitor the activities of the kids. Plus, at the same time, even in the normal schooling hours also, okay, right, there are certain trivial topics where the students don't need help of the teacher, okay, in the classroom, okay, which is completely monitored by the robo itself, okay, right, in terms of assignments, in verification and lot of those things. So in all those kind of systems, which is IoT enabled, it comes with artificial neural network also. Another question is that how to implement a smart meter concept in smart microgrid using IoT. Sir, just to give an answer, okay, right? I'll tell you how it works. So it is basically like already this solution is there in the open market, okay, right? Schneider Electric and as well as even a lot of other players, okay, right? GE, okay, right, and a lot of other global MNCs, they have already rolled out products on smart energy meters, okay, which are based out of IoT technology. The mechanism it works, it is very simple. What happens is that your energy meter, okay, right, has a sensor, okay, right, which basically also has a, I mean, it also has a node MCU. That node MCU is connected with Wi-Fi, right, and that Wi-Fi network, okay, it is connected to the, I mean, that Wi-Fi network, either it gets connected to your broadband at your home, right, and through that it gets connected to the local power supply station, so that it continuously keeps a track of power utilization pattern in your home, okay, right. For example, if they see that, okay, right, a lot of loading which is keep increasing, okay, then accordingly they will keep sending messages to you. In fact, our city of Ahmedabad in India, okay, right, has implemented effective water utilization through this mechanism in their homes. For example, depending upon the number of people, okay, in a home, the amount of water supply is restricted to them. And if there are visitors and there is a more amount of water is required for on a daily consumption, then automatically through their app, okay, they can think that, okay, this is the number of people in our home because of the inflow of visitors, then automatically the water supply, limit will be increased to them. So that is how it is being managed. And if you want to see a demo of these things, how it works, you can also visit our office. We have our electrical renewable energy system solutions where power is getting captured, okay, right, from solar panels, okay, even in a domestic setup, right? And if the home is not using all that solar power which is extracted from the panel, then there is a mechanism of throwing that power to the grid today. Okay, in fact, already this is not a new phenomenon, by the way. It is already happening in apartments and as well as big educational establishments. For example, St. Joseph's College in Bangalore, okay, not today, I'm talking about from the last 7 years, they are not consuming any power from the BESCOM. In fact, they are supplying power to the BESCOM and they are earning revenue. So how it is working is that from the solar panels which is being set up in their campus, lot of power gets generated, and that power, whatever that goes as a consumption utility at the end, it goes to their utilization. Rest of the power is thrown to the grid, right? And for that smart energy metering will take care of how much amount of power inflow is happening from the grid to end utility node, and at the same time how much amount of power it is basically fed back into the grid. So based on that, the billing adjustments will happen, and net payable to mutually either to the consumer or else to the power supply company is taken care. And in fact, this mechanism St. Joseph's has already implemented several years back, and now this is very much in action with many apartments and big building and establishments, okay, communities, not only in Bangalore, across India and worldwide also. So if you want to see a demo of these things, how these things really work, we have a setup in our office in Bangalore at Indiranagar. Feel free to visit our office. Our technical team can run through that application for you.
Hello, excuse me, sir.
Hello. Yes, madam.
Yeah, thank you so much, sir. Actually, if the thing here explained, the demo thing, I am working on Simulink model. Like I have the grid connection model on that, and I have to implement this IoT. So I am not able to do that, sir, because like you are saying, this is practically possible. Like we are implementing the solar rooftop at our home, and so the two-way communication is possible. What if in the Simulink model I have to use the smart meter concept and how to implement that IoT techniques on the Simulink modeling and simulation, sir? I am not able to do that because there is a problem. I don't know how to implement this concept on the Simulink modeling because mathematical model I am not able to make it because after all, after making this mathematical model, I have to go for optimization technique. What will be the suitable solution? But
Yes.
so I am stuck in that only. Okay, how to implement in Simulink model this concept?
Yes, madam. Okay, once again, we have our solutions in that direction. Okay, you can visit our website and let me see, I can do the screen share and I can show you right away. I hope my screen share is working for you. Is it?
No, sir.
No,
It's not
okay.
sure.
Let me do the screen share. Hope it is fine now, right?
Yeah.
Let me go to my company website. So here we have a product, okay, right? Yeah, here comes. Okay, you can see this product, okay, what you are seeing. Products, okay. This product, madam, okay, right, helps you to address those things, in fact. Okay, it is very much supported with model-based development. Okay, so since you said that you are working on MATLAB, Simulink, you
Yes,
can
sir.
see
Yes,
this.
sir.
Our product is also based on MATLAB and Simulink based, and all the algorithms, okay, right, and R&D work, what you intended to work upon for the smart
Yes, sir.
energy, okay, metering system, you can very much explore these things. And another powerful capability of this product is that it is built on FPGA. Okay, right. So as a result, you want to customize your algorithms and port on the hardware, and you want to test verify your results, you can do that.
So there's this power quality also. Is there any meter you have developed a power quality analyzer that are
Yes,
going to
madam.
check the
Okay,
power quality?
yeah, that's what, madam. Okay, this product, what I'm just sharing with you, it is basically a rapid control prototyping setup, which can support all these applications like solar energy, motor drives, power quality, microgrid, electrical vehicle. So the application areas which it can touch is quite wide range, in fact. Okay, right. And in fact, this product is basically the triggering point, okay, for people to get into even e-mobility sector also, because after a couple of our customers seeing this product and capability, they asked us to help them in e-mobility solutions. And today, in fact, we are providing battery and as well as battery train and as well as a lot of electrical drive solutions for the right leading automotive players, okay, right, in their electrical vehicle products. So my request is that please go through the details. If in case if you still want to know more about this, and if there is a provision to have a remote demo and something, okay, for your team,
Yes.
you can do so. You can do so, madam. You can drop a mail to Mr. Somashekar. Som, can you share your contact details in this group, okay, so that madam can communicate to you for Vivek. Or else even if you can connect her to Abhishek, so that Abhishek can help her.
Okay, thank you so much.
Yeah, you're welcome.
Damodar,
Yes, sir. Yes, sir.
there are two questions in the YouTube live chat from
Okay.
Shivalinga Hunagund. He asks, instead of a cloud, any other things can be used in the layer 3.
Sorry, sir. Instead of cloud,
Any other things can be used.
yes, sir. Very much. Cloud is only an option, sir. Okay, right. There are alternatives also. For example, if we would like to have our own local storage, right?
Okay.
So we can have our local storage, but that will not make your solution cost effective, because you need to set up, for example, today if I am supporting through my application some small number of subscribers, then probably I can set up a storage, okay, right, in my office or else in my commercial establishment or home for limited customer base. But tomorrow, if my customer base increases to probably thousands of users, then in that case, then I have to increase my storage at home, in fact, or else wherever my business is running. So that's the reason everybody is very much looking at scaling their application usage. Okay, right. So that's the reason they are going with cloud as one of the elements. But if in case if any of you want to have your own storage, okay, right, instead of going for cloud, okay, open cloud, or else even paid cloud services from Amazon, Google, or even Microsoft, so you can very much do so.
Okay, thank you, Damodar. There was one more question which is asking for put some light on edge computing. Is it possible now, or we can have some other time?
See, in case of, can they elaborate what is that exactly they are looking in edge computing?
No, he has not very clearly mentioned about it. He just want to, I think, introduce with him, with the edge computing concept. Nothing
Okay,
else.
so my request would be that if they can elaborate a little bit more on what is the specifics of edge computing which they are looking at. Okay, right. and they are open to drop a mail to us at training@ntupel.com, right? So we'll respond back to them, sir. Okay, we only suggest them to leave their contact number so that we can call them and we can assist them.
Yes, yes. Thank you. I think we will close Damodar. I think there is no more questions in the chat box as well as on the YouTube live chat also. I'll just propose vote of thanks and we can close the session. Is it okay?
Yes.
Or you have
Yes,
anything
yes, sir.
to say to participants?
We are done with from our end. Okay, so we request them to contact us. Okay, if they are looking for any further information in this direction, with the contact details what we have shared. So they are very much free to contact us. Okay, in that regard.
Yes, yes. Thank you. I'll just propose vote of thanks. Uh, I would like to thank Damodar and Arvind for enlightening us with the IoT sim and its layers, and with that they have explained us what are the different applications where we can use the IoT weather station, data analytics and IoT, the machine learning in IoT, as well as AI in IoT. I thankful to Damodar and Arvind for the wonderful session. I'm really grateful to Damodar and Arvind, and also Somshekhar of Entupal Technologies Private Limited, Bengaluru, for spending family time on weekend with us. I'm very sorry for that, Damodar, but it was a need of an hour from our end also. And I would like to thank Somshekhar, who is instrumental in convincing Damodar for this weekend session on role of AI and machine learning in IoT. Thank you, the Entupel Technologies, for the wonderful session, and a lot of information we have gained from it. And if the participants have any queries, definitely they are going to be in touch with you. Somshekhar, I'll be sharing the registrants information tonight, and you can make use of that. Participants, we will start our next session by 11:50. Please take a tea break and join back at 11:50. Thank you, Damodar, Arvind, and Somshekhar, if you are there.
Yeah, thanks, sir. Right, wish you productive sessions further for all the participants.
Yes,
Thanks.
yes. Thank you. Thank you. Thanks a lot. Bye. Good day. Mansa madam,
Hello, sir.
ನಿಮ್ಮನ್ನು ಪ್ರೆಸೆಂಟರ್ ಮಾಡಿದ್ದೀನಿ.
Audible, sir?
ನಿಮ್ಮನ್ನು ಪ್ರೆಸೆಂಟರ್ ಮಾಡಿದ್ದೀನಿ, ಚೆಕ್ ಮಾಡಿ.
Yes, sir. Sir, can you see the PPT, sir?
Yes, madam, yes.
Is it okay, sir?
Yes, madam. There is small patch here at the bottom.
Sir, that when you are speaking, that message will come, that is coming.
Okay. Can you push it somewhere else? Is it possible?
Is coming. Yes, sir.
Yes, yes.
Yeah. I can start, sir.
Yeah, I'll introduce to the participants.
Okay, sir.
Okay. Good morning, participants. Welcome to the last session for today as well as for the webinar series. I'll introduce today's resource person for the session tips and tricks for TI TINA. Mrs. Manasa KR, she is presently working as assistant professor in the Electronics and Communication Engineering Department, School of Engineering, Dayanand Sagar University, Bengaluru. She has completed her Bachelor's of Engineering in Telecommunication from Sri Siddhaganga Institute of Technology, Tumkuru. She did her Master of Technology in Computer Network Engineering from National Institute of Engineering, Mysuru. Currently, she has registered for a PhD on antenna design for high frequency applications under the guidance of Dr. Rajashri Narendra at DSU Bengaluru. If you look at her teaching experience, she has 2 years of teaching experience with SIET Tumkuru as a lecturer, and she has 6 years of assistant professor experience in MIT Mysuru. From last 2.5 years, she is working as an assistant professor at DSU Bengaluru. She has handled electromagnetic theory, the signals and systems, antenna and wave propagation, computer networks, network security, optical networks, and many more subjects for undergraduates and postgraduate students. She is a life member of member of IST and student member of IEEE. With this brief introduction, I'll request Madam Mansa to continue with the session. Thank you.
Thank you, sir. I will start with my session by inviting all my friends. Here I am presenting tips and tricks for TI TINA, and let us see that what is TI TINA and what are the features we are having and which type of simulation it is, and also which type of circuits we can break up here and do the simulation. And here there is an agenda. Here we are discussing what is an introduction for TI TINA and mainly the key features for TI TINA and minimum hardware and software requirements and installation procedure for the TI TINA. I am not going for in detail because all we have know how to install any software, only to give the link where you can get it and how to build a circuit using TI TINA and which are the analysis capabilities we are having it. And here, along with the analysis capability, we should also know that which are the virtual instrumentation we can do it, because we know that any electronic circuit or either it can be a digital circuit, sometimes we require external instruments to give an input as well as to see the output. And then we will go with the hands-on. It means I will execute and some of the experiments, and also I will show that how to rig up the circuit by using TI-TINA, and also I will go with the additional feature of TINA. I will tell you what is the difference between TI-TINA and TINA when we are presenting. So let us go with the introduction. And here it is a TINA TI. It is a free circuit simulator, and it is done the designing by using a Texas instrument along with the collaboration of DesignSoft. And mainly the Texas instrument using this software for rigging up the circuit for the simulation before implementation. And TINA TI is a powerful circuit simulation tool, and it is having a, actually why I have given here only the simulating of analog and switched mode power supply circuits is because our free version can able to do it only the analog and switched mode power supply circuits, but it is not allowing us to do the digital part as well as the additional features. Only in the licensed version we can get all such capabilities, and this tool is helping whenever we are designing any analog or SMPS circuits. And it is very easy also, and a straightforward transition it is. And you can say that TI-TINA is a limited powerful version. Why? Because TINA, what I told earlier itself, is a main version. There also you can identify many versions. So here it is a smaller version or a small portion that is collected from the TINA, so it is a limited version. And mainly the key features of this TINA TI will be the first one is nearly it will allow 100 SMPS models from Texas Instrument, and also it will be almost 10 times faster, and it is a 15% more well code and other features also. And fast diagram drawing and processing speed is the main key feature for this. And multiple scroll bars can also be, and multiple windows you can open here actually. Because many pop-up windows like a different type of the waveform, if you want to see it, yes, you can see here. And there is a combinational and a parallel stepping also it is there in separate cases. And one more thing, it is a node list, is a post processor shows the name and the node names also in the relevant macros. Along with that, you can identify another features are, you can see the gain margin as well as the phase margin. Here you are allowing only, we are allowing only the linear circuits to rig up. And the ideal op-amp is also present here to analyze it. And here, one of the key features is while running any like circuit or anything, you can minimize the software, and also you can open a multiple windows. And you can also do the zero crossover, the position cursors and everything is there. Along with that, mainly ERC check, it is an electronic rule check is also available to check the circuit whether everything is connected properly or not. And open example command also it is present in the file menu. And whenever you download your software, automatically you can get some of the example circuits that also you can see that and you can execute it. They will also provide along with the circuit how you have to conduct an experiment and which are the outputs you have to see from that. And mainly the minimum requirement for hardware and software will be Intel Pentium processor. It's okay, below version will also be allowed, and 256 MB of RAM is required and 200 MB of hard disk space is required. and mouse is required to rig up the circuit. It will be easy, and VGA adapter as well as adapter card and the monitor. Then any of the platform it will be applicable. Let us go with the installation procedure. You can download TINA TI from the TINA TI web page itself. Alternatively, you can also download it from the home page, that is www.ti.com, and you can also go for TINA TI web page also. But in the web page, you have to download the first portion. Part number or the first one, whichever you can identify. I think you can see the cursor. The TINA TI English Analog Spice-Based Simulation Program, where you can identify this. This you can download it, and that will be a free version. And you know that whenever you start with your simulation procedure, obviously you will be finding so many pop-up windows, and sufficiently give all the information. And once you download your software, then automatically you can see the first page of the TINA TI or the initial page of the TINA TI that you can observe like this. And after the installation, you will find out when you open your TINA TI, it will be looking like this. And here you can observe that the top window which gives you the menus. And here you can observe that the second row, which gives you the file operation, text, hide and writing features, all those things will give you. And the third and fourth option, which is giving you the icons as well as the tabs. And one more thing, in the free version, you can identify only this many tabs and this many elements to rig up the circuit. But whenever you go with the higher version or a licensed version, you will identify so many. Here you will get the digital circuits as well as HDL, VHDL circuits, because you can identify so many parameters like a microcontroller and PCB designing, everything. Those things you can identify. But in this version, you can able to see only these many tabs. So let us go with initially, just I am showing you which are the steps and how you can rig up. Initially, when you start building the circuit, obviously the steps to be followed will be, initially any tab you have to select it, which device you want it, that tab has to be selected. So here just I am choosing the spice tab. After that, you can identify so many symbols here. You can identify here a differential op-amp, ideal op-amp, other than that SMPS comparator, as well as DAC and ADC, so many parameters you can, so many elements you can identify. Any one of the symbol you can select it. When you select that symbol, automatically it asks you which of the series you have to select. Here you can identify the series, which operational amplifier you wanted. You can choose that operational amplifier and then click OK. Then that element will be there, and it will be a mobile element. When you click the on the screen where you want to place your element, there it will be pasted. Then along with the element, you should also join so many active and passive components like a power supply and the connecting resistor, capacitor, inductor, whichever the circuit we need to design it. All those things you can do it. And here you can also identify there is a jumper connection icon. And why it is given jumper connection is here actually we need to give for the op-amp like a plus VCC and minus VCC. If you start giving your DC power supply here itself, then the circuit will look so complicated. So you can somewhere else you can place it and label both the sides say with the same name, then that will be connected. That is the meaning of this jumper. And also you can select any of the passive device. After selecting any device like a resistor, capacitor or anything, you can also see that all those parameters you want to control regarding your resistor, that you can do it here. So resistor value also can be changed, and the power watt resistor you are using, along with the temperature control if you want to do it, and linear temperature coefficient. So many things are there. So all these things you want to provide, you can provide all those things and click OK and place where you want to place it. And then afterwards, after getting all the element, yes, obviously we need to arrange the element. Along with arranging, we should also connect each element with each other. So wiring should be done. Here the wiring operation will be selected from this. And here you can join from whichever point to whichever point you require. I think from the circuit you can also observe that here V minus and V plus is given, that is plus VCC and minus VCC that is given with the help of your jumper connection or the jumper usage. So in this way, somewhere you have connected, but with V plus and V plus same name is given. It means this and this is connected, and V minus and V minus is also connected. And here along with, after the rig up, obviously we go with the analysis of the circuit. First analysis we do will be the electronic rule check, and from this we can able to identify that whether all the connections are proper or not. Sometimes any one wire is connected one above the other, and double connection also it will show, and wherever if you miss the connection also it will show all those things. And once you get no warnings and no errors, only then you can go with the other analysis. Along with this electronic rule check, we can also identify the DC analysis and the AC analysis, transient response also you can see, Fourier analysis and noise analysis. And don't think that only we can identify these analysis, but it is restricted only for the free version. But when you are going with the licensed version, either you can take it academic teaching version or the student version also, but only slight difference with the industrial version and this. Only thing that the number of elements that we can available in the TINA will be more in the industrial version, as well as the number of nodes that can be there in the circuit will be restricted in the electronic, the student version and the academic version. That's it. But still with that restriction also we can able to design so many circuits, and many analysis capabilities also there in the higher version, like generating the transfer function also is present, for example, and like that you can identify so many analysis capabilities in the TINA. And whenever you do with the electronic rule check, it will be look like this. I have taken one example circuit, and when you select under the analysis, initially you have to check with the ERC, that is the electronic rule check, and you will be getting this pop-up window. And here you can observe that it is telling that the graph generation is okay, and you are not having any error and a warning. So therefore, if that is the case, then you can close it and you can go with the another analysis capabilities. And I have taken one of the example also here with error, same thing, analysis and ERC check. When we are doing the pop-up, it gives you that one of the warning is there, and which is that point will be here the wire connection. And one more thing, on this window, electronic rule check pop-up window, wherever you are getting a warning on that, when you click it, it will show on which location you are having that warning. That also you will be available, that you can do it, and you can rectify your circuit and completely without having any errors or a warning. That time you can execute your circuit. And here we are seeing that the DC analysis. Why I am showing all these things before going to the hands-on is the steps we need out.
Madam, nothing. You can continue. Few of the participants have joined.
Okay, sir. Thank you.
Yeah.
the steps that we need to follow when we are doing any of the analysis. To show that one, just I have taken, these are the examples. Yeah, whenever you want to do with the DC analysis, go with the analysis, and here you have a DC analysis. Along with here, you will be having so many parameters like calculating the nodal voltages also you can calculate it, and table of DC results also you will get here, and DC transfer characteristics you can check it, and temperature analysis also on any of the device you can do it. When you click the table of DC results, then it will open again another window where it will be containing all the voltage values in every device. It means every active and passive element, as well as what is the current which is flowing in all the network. And here it takes some of the node with the names, and whichever node you are clicking, that will be there here, and you can observe that. So from which point to which point, for example, if you are having a node like 5, then obviously from 6 to 5 what you are getting, from 8 to 5 what you are getting, all those details will also be available in this voltage and currents window. Sorry. And next we are going with the transient analysis. Yes, we know that the transient analysis, it is mainly required such a circuits like a oscillators. So here the steps that we need to follow to get the transient analysis will be first one analysis, then go to the transient analysis. Then afterwards you need to keep that the display from which point to which point you need to get the display, that you have to specify here. That is from 0 to 10 milliseconds I have chosen here, so that you will be getting. Why I have taken here is, yes, we have designed our circuit itself is for the 1 kilohertz frequency generator or an oscillator. So therefore, if you are taking 1 kilohertz means you will be getting a 1 millisecond as your time period. At least if you want to get 10 cycles to check it out, then we are giving 10 milliseconds. In that way you can give it, and apart from that you are also having, there is a 3 other parameters. You can able to calculate the operating point, or you can use any initial conditions if you are having, and you can also find out with the 0 initial values also, and you can get the draw excitation, or you can close the draw excitation if you are not required for that. So after selecting all those things, give it OK, then you will be getting, this is the 4th window that is providing the transient response for this circuit. And the AC analysis, if you want to do it, for the AC analysis here, and we know that whenever we are giving the AC input in all the devices, you are not just giving getting the voltage values, along with the phase value also you will be getting. That you can get it from the table of AC results, along with the magnitude and the phase, both you will be available. So here AC analysis, and in AC analysis we are going with the AC transfer characteristic. Under transfer characteristic you will be getting the amplitude or the magnitude spectrum as well as the phase spectrum. Both you can observe it. Actually I have taken here the low pass filter, and in low pass filter we have designed. Yeah, you can observe in the circuit. I haven't used any jumper here. Directly I have provided with the voltage supply, that VCC and VDE. VCC plus VCC and minus VCC to the pin number 4 and 7 here, and I have executed. If your circuit is very big and you want to give the same power supply for the 2 or 3 pumps, then you can design that power supply junction circuit somewhere else, and that the same name can be provided for all the pumps, and you can avoid using the number of elements in the circuits and make your circuit will be easier. So therefore, this is the magnitude and the phase spectrum. And here you can observe there is a cursor A and B. The cursor will give you X and Y value wherever you will place it. And we know that from 0 we need to go with the 3 dB down. So when you go with the 3 dB down, exactly here you will also identify what is the frequency you have got. That will be your cutoff frequency for the low pass filter. And the parameter stepping is the additional feature that you can observe here in the Tina TI. What is the meaning of that will be? For example, we know that this R and C value, what we have taken, those are the values which is actually changing your cutoff frequency. So therefore, either you need to keep your capacitor constant and resistor change, or you can keep your resistor constant and capacitor variable. In that way, you can do it for seeing the many cutoff frequencies and many windows, and all those things can be seen in a single window. That is the main advantage that we are getting it in the parameter stepping of this Tina TI, that we are doing it because we know that F that we are getting will be a 1 by 2 pi RC is the circuit. Anyway, one will be a kept constant, another when you are changing, obviously the frequency will also change. How you can do it? The first step will be after rigging up the circuit. First one here you can identify this is a parameter stepping constant, and this you have to select first. And after selecting on which element you want to provide the parameter stepping, that you have to click. When you click on this, automatically it gives you the another window, this, and after getting this window, here the value has to be changed with your resistor. When your resistor has been changed, the value of the resistor has been want to change, and click on this 3 dots. After clicking on the 3 dots, it gives you another window where you want to control your object which is selected. So here, which is the start value you want to give, that you can give it. What is the end value for the resistor also you can give it. And how many cases you want to get it, that also you can provide it. And press OK. After pressing OK, now this is used as a parameter stepping. Once again, go with the analysis and AC analysis. Under that AC analysis, transfer AC characteristics. AC transfer characteristics, and there when you click it, then obviously once again you will be getting the magnitude gain plot and the phase plot. Gain margin and the phase margin you will be getting it. See, you can observe here this lighter green shade which is having a different cutoff frequency, and the little darker green is having another cutoff frequency, and the red one will be having another cutoff frequency. These are the 3 different values what we have given as a stepping for this controlling this object. And same way, whenever you want to remove that characteristic also, same way click on this, and secondly you click on the resistor which you have already given for the controlling. Again you will be getting this resistor window. Again you need to check, click on this 3 dots, you will be getting this again control object selection. But here now you have to give the remove option. Now it will be removing that parameter stepping option, takes only the one value which is given statically when you have choose your device or the element. Click OK, then you will be getting only one response. And along with that, we are also going with the test and measurement options. And yes, I also already told you that along with the analysis, we are also want to see that which are the devices we need to see, use it as an input device as well as an output devices. Here in P&M, it is under this element, you will be getting a function generator, multimeter, XY recorder is also there. Along with that, oscilloscope is there, it means CRO. Then the signal analyzer is also there. But now, only for the simple purpose, I have taken here the oscilloscope. First, you have to check, click on the P&M. There you will be identifying the oscilloscope. Along with the oscilloscope, yeah, when you do it, here you will be getting. And here, one thing you need to observe, if you are having so many parameters to identify, because we know that whenever we are using a CRO, sometimes we want to see both the input as well as the output waveforms in one screen itself. That also I will show you how to get it, and that can be controlled by using your X source. Here, when you click on this, whichever sources you are having, source means either it can be input source or it can be output source you are having. All the things will be listed. When you click any one, then that output you will be watching in this display window. After that display window, if you want to see that output in a just a response format, and here you can also export that one. So once you export it, you can see that regular whatever the output we were watching it earlier when we got it in an analysis. So same window you can also observe here. And all these things which is having a control element, either you can go with the triggering element and horizontal, it is nothing but your amplitude scaling as well as a time scaling knob what we have identified in the CRO. Same thing we are getting here. It is horizontal which gives you the time scaling and vertical which gives you the amplitude scaling. Along with that, the position window is on, position knob is also present here. And you can observe here another virtual instrumentation. It means I have used both input device as well as the output device. You can observe here by controlling, as I already told you in the previous slide itself, we have, if we have so many outputs, all the output you can observe it. One of the main advantage if you want to see this type of a circuit is, see, whenever we want to see like RC phase shift oscillator itself, we know that first combination of RC we will be getting the 90-degree phase shift. Another one will be again 60-degree phase shift. Next one again 60 degree. All the three things finally you will be getting the 180-degree phase shift for your oscillations. What you will be getting it. So, if you want to see all the variations, then here all the windows, all the waveforms, you can observe it in the oscilloscope. That is the main advantage. But we know that only in the digital oscilloscope PSO, we have that one, but only thing that we need to save and we need to just show it. But time coincidence will not be present in the regular oscilloscope. But here in the virtual oscilloscope, even one of the example what I can mention is a QPSK, where you want to see so many waveforms. So all the waveform you can observe it and you can see here in this window in a single. All these things you can see, and I will show you when we go with the hands-on. So, as I already told you, here we are having an option of displaying two signals. Why? Because I have used it two elements. One is the input device, another one will be output device. Output device also, it is not necessarily always you need to use a AC voltmeter. It is there so many parameters like a multimeter also you can see. And from the oscilloscope, if you want to see, then open source is there. Along with that, like a probe connection is also present here. So many types of the devices we have in this TNAT TI. And by using any of the device, you can see your output, and all the things can be connected with the oscilloscope also. And here one more thing, another input here we have used, that is sinusoidal signal generator that is required for the half-wave rectification. And here I have used a function generator. In the function generator, you have controlling of many parameters like a frequency you can give it, and the amplitude also you can give it, offset values also you can give it, and phase also, with what phase if you want to see, that also you can see it. And along with that, you can select either you want to generate a waveform which is a sine wave, or it is a triangular wave, or it can be a sinusoid square wave, whichever the way you want to generate it, and those things you can give it here. And all the things that can be editable by using this tab here. When you click any one frequency, if you want to change, click on the frequency, then go to a edit option. Then you can change here the values, and then you can see the output. And the additional assistance which we can get it here will be as I already told, another analysis will be a steady state solver is also there, and the Fourier analysis can also be done it. And here in the Fourier analysis, you can see that what is the Fourier series, you will be getting it. And when you click on that, you will be getting this window, that is a Fourier series window. What is the sampling start time also you can give it, what will be the base frequency, and number of samples you want to get it, that also you can give it, and how many number of harmonics you want to give, all these things you can get it. And the format also, here what is the meaning of a format is, we give it in the Fourier series, we have a many types to represent, either it can be a trigonometric representation, or it can be exponential representation. So you can choose it here, the trigonometric representation also, or you can get the all the harmonic values by using the exponential Fourier series also. Any which format you want to get it, on that format you have to select it and click calculate. When you click on the calculate, then below this here itself, you will get all the harmonic values. You will get all the harmonic values, and you can note down all those harmonic values. If you want any of the help also, if you click on this help button, it gives you the helping of all those parameters. If you are not getting anything to be set here, like a sampling rate and the base frequency, number of samples, all those things, if you are not able to set it, then you can do all these things. Let us go with the hands-on. Here I will show you with a very simple circuit how to rig up the circuit, and afterwards I will show you some of the experiments whichever I have conducted, and from each experiment which are the analysis that we can see it, and how all the parameters can be given it. Prashant sir?
Yes, madam.
Sir, you can visible, sir?
Yeah, it is visible, madam.
Yes.
Yes.
Thank you. I'm taking you this very simple experiment. Yeah. Because only to show that how the parameters can be controlled, let us consider the resistor. And if I want to generate a RLC circuit, L also I need it, and C also I will consider. And along with that, I require the input also in this input. And one more thing here, see, whenever you click out, you will be getting all the devices in a green, and click on the label. Wherever you want to place it, you place it. Why? Because in the circuit, sometimes if you are not doing all such things, then your circuit will be looking so clumsy, and you cannot identify which device is labeled with what name. So therefore that you can do it here. And here, to control all the things, before controlling all the things, let us connect all the devices. I am clicking here the wire. From the wire, I have taken from one device to another, and here, like this, here, and from here to wherever you want to go, you can click here. And we know that we are giving only the input. I am not given any output here. Why? Because I want to show you without connecting any output device, how your response will be visible. Even then you can see that what is the current which is flowing in the circuit and what is the voltage drop across each element also you can see that. And one more thing to remember here, whenever you want to alter any value, double click on this resistor and you can identify here. You can change the name of the resistor also, because in sometimes we require like a load resistor, or it can be a RB resistor, or it can be a RL resistor, or it can be a RC resistor. So only to see our circuit will be like a manual format itself, and also to be a readable format and also a understandable format. You can change your label also. Along with that, you can also change the value for that. And here, if I am giving like this, if I give and just enter it, it will automatically take that 1.22K I have given it. And similarly, you can
Manasa,
also
madam.
control. Hello, sir.
Can you zoom the screen, this thing, circuit diagram?
Yes, sir.
Yeah, thank you.
Yes, sir. Yes. And you can double click on this. You can see the label, and here you can change it. Along with this, and you know that always the tolerance value will also be present for any of the passive element. And so that also you can give it, because we know that in the resistor, whenever we are telling any student to read the value of the resistor, along with the value, they will also say sometimes what will be the tolerance that is given, because we know that we have identified if we are having a silver and a gold line that tells you with what is the tolerance value for the resistor also. So that value you can give it, and all the parameter, it is not necessarily all these things to be given, but if you want to control all the parameters, you can control it. I think someone is having any doubt, sir.
Madam, there is a query in the chat box. You can just see that.
Yes, sir. I think after completion, I can clear all the doubts.
Yes, madam, no problem.
Yeah. And afterwards, you can see this, and along with that, here we need to connect this, and it is not only it is a symbolized, and this controlling can be done even by using a frequency generator, but it is just a simulation what I am doing it without having any instrumentation. I have taken one of the AC signal generator. So double click on this again, you can identify the name, and here the DC level also you can give it, and the which type of the signal you want to give it as an input, that you can do. So here, whenever you want to control on a signal type, here you can identify the unit step. Click on this, you can identify 3 dots, and click on the 3 dot, you will be getting a signal editor window. In the editor window, there is an option of selecting the pulse signal, and here in the pulse signal, you can change the value of the amplitude and also what will be the width of the pulse also. And along with that, you can select a unit step signal, but here it is told as a unit step signal. That's why they have taken it as a amplitude 1, but you can do it as just a step signal with any of the amplitude. And then sinusoidal signal. In sinusoidal signal, again the amplitude you can give it. And it is not, if I am giving the amplitude as a 1 volt, it means V peak to peak is a 2 volt. So from -1 to +1, your signal will be varying. And you can also change the frequency. And if you want to change the phase of the signal also, you can change your signal frequency. And here you can observe that as you are changing your frequency of the signal, automatically it gives you what will be the period of the signal also in this window itself. And along with the sinusoidal signal, you can observe here, you can also generate a cosine signal. Almost it is same with the cosine and the sinusoidal signal. If I am considering a sinusoidal signal and which I give you the 90-degree phase shift, then automatically it becomes a cosine signal itself. So that's why, it is your wish how you are using it. So cosine signal is also available. Along with that, here you are having a square signal. In the square signal, again the amplitude of the first signal is considered and the frequency of the signal is also taken. What is the meaning of the frequency here? It is nothing but, so what will be the totality of one cycle you want to consider the square signal also can be decided by taking this. Because here, if I want to generate any signal which is having a 1 millisecond frequency signal, then I have to find it out what will be the frequency, and that frequency I have to give it to. Along with that, if you want to give it rise time and a fall time also. So if you are giving very, very lesser value to the rise time and a fall time, then automatically it will almost look like a square signal itself. Otherwise, it will be considered as a general signal or a trapezoidal signal. So that also you can get it. And here you can either give like a triangular signal also there. So in triangular signal, what will be the amplitude you are giving it and what is the frequency? Once again, here the frequency is nothing but your period itself. What is the one cycle period? Other than that, generalized signal is also present here. The generalized signal you can vary here the values. For example, see here the amplitude. This can be varied like 2. So this is changed. Along with that, here this value is also changed, and the frequency can be varied. See, once I click on the separate value. So this is taken as a 2 volts and this is taken as a 1 volt. So these changes can be made at which type of the signal you want to fit it. That type you can change the values for T1, T2, T3, T4, T5 and T6 values. They have provided to change the 6 values, 6 parameters can be changed, and the time shift also you can give it. So apart from that, here you are also having a piecewise linear characteristic is also considered, but one thing that in the piecewise linear characteristic, when you go for the menu and or otherwise test window, you have to first choose which one you want to get the piecewise linear structure, and when you choose that one, only then you will be getting it. So here, at present we are not getting this, but you can do this piecewise linear also. Along with that, you can import any of the wave file. For example, if you are using any speaker and you need to give any bird which is giving that sound, that voice, if you want to give it as an input, that also you can do it. But only thing that from the internet you have to, or from the Google you have to download that wave file, and that wave file you have to load it here, and that wave file will be given as an input here. And it is almost look like a noise signal itself, because that signal is not represented in a mathematical formula. So that's why we consider it as a noise. But it is not a noise signal, it is a wave signal. Any wave signal you can load here and you can execute it. But at present I am taking a sinusoidal signal. I have taken 1 kilohertz as my signal. Then obviously when you click on the 1 kilohertz, you can see here once again what is the time period. 1 millisecond will be the time period that you can observe here. So click on OK. You will be come back to this, and it is your wish to give what is the DC level. So here the DC level I have taken 0 itself. If you want, you can change it and click OK. Once you give all these things, go to a analysis, and remember here whenever we are going to the analysis of this, we know that all the elements which is capable of giving the AC analysis, because the signal which we are giving is also a AC signal itself. So therefore, what is the voltage drop across each of the element, we can observe it. Along with that, what is the current which is flowing in the entire circuit also can be observed. So for that, seeing all those things, I am going with the AC analysis and table of AC results. So I think you can observe here. See, when you expand the window, can you see this? This window can be seen only with this font size. Yeah, here you can observe, as I already told, whenever we are giving any input, see, one more thing, when I click on this 2, you can observe here what is the voltage you are getting at that point. Okay, and this is again, we are not having that. Anyway, this will be the point. This is 1 volt with a 90-degree phase shift, we are having it. And one more thing, whenever I want to see this 0, it means 0 to 1 will be, or otherwise whenever I click on the resistor, these points I cannot see. I can see here VP1, what will be the value, and you can observe here what is the current which is flowing. Obviously, this is a series element. All the elements which is having a same current which is flowing. Only thing that the phase will be different in the capacitor as well as the capacitor. So this is the voltage drop across the capacitor, voltage drop across the inductor, voltage drop across the resistor, and this is the voltage what we are giving here, that is the signal. All these things you can see it, and here you can also see that one more window, the I symbol. When you click on this, you can get another option that you can save. And one more thing you can observe here, it is showing all nodal voltages and the current which is flowing and the other voltages whichever you are having, as well as the output what you will be getting it. So if you want to see this as a output, one more thing, see I have taken only the values how to see it. But if I want to see it as a waveform, then I will go to a meters. It is your wish which is the device you want to fit it. So here you are having a devices. This is the voltmeter also you can get it. Along with that, here you will be having a open source. So whenever you want to see across all, so click on this and I will rotate the signal. When I rotate it like this, you will be getting it. This is the first one, and this is the voltage drop across the resistor, so that you can name it here. And this also, for example, if you want to name this also you can rotate it and you can place the things. And again, another open source. This is again I am rotating. I am placing across this. Again, one more voltage source, placing across this. I will be giving, and this will be the voltage across inductor VL, and this is rotated, and this will be voltage across the capacitor. And now you can connect all these open source like this. And one more thing, remember, whenever it is not connected, it will not show this connected black dot. Without that, you can clearly identify that they are not connected properly here. So that you can observe it. I have given like this. Okay. And here I want to see the output. whenever we have given here the frequency for the signal will be will be 1 kilohertz I have given. So therefore the time period will be 1 millisecond. So if I want to see the output of all these things, go to analysis and select the transient response. In the transient response, as I already told you that the start will be always 0 and end will be how many cycles you want to get it. So according to that, the cycles you need to select. If one cycle requires 1 millisecond, if I require 5 cycles at least, then I need to give 5 milliseconds. Then after giving all these things, click OK. You will be getting like this. And you can observe all the waveforms which is given like this itself, but you are not able to identify what is the ER signal, what is the VL signal, what is the VC signal, and what is each one signal. So therefore, here what I am doing is go with the view, and we have an option that separate curves. Give a separate curves, you will be getting all these things. If you want to see your waveform in a bigger way, you can do like this. And one thing you need to, if you want to see is in an order like the input signal is first, then VL, then VR, VL, then VC. If that is the case, what you have to do is while name it itself, put this as 1 and then 2. Third signal, and this I want a fourth signal. Like this I have given it. Again we'll go to a transient response. Anyway, previous value, whatever you have given it, still it will be there as that one itself. Like this you will be getting, and go to a view, go to a separate curves. I think now you are very clear that, see here, first you will be getting the input signal and then we already know that always resistor will be in phase with the input signal. PL and VC will be the out of phase with the signal. So how much phase shift that is happened, that is already observed when we have seen an AC table for AC table values. In the table itself, we have understood that what is the phase difference we have obtained with respect to the VG1. So this you can observe it in the response. See here, what is the main advantage for this will be, if you want to see the previous results also, that will not be realistic, close your TINA TI. So for that, go to a TR first result, see unorganized waveforms we had it. Now it will be an organized waveform we are having it. Both the signal you want to see, you can see both. So this is the way how we need to connect. And one more thing, yes, this is a very simple circuit, it is working, but one thing that don't forget to use this ground connection. And if you want to see what is a changeover that is happening in your waveform, yes, separate curves, see the waveform, and if you are having any changes, then you can see all those things. And the phase difference, what we are getting also, you can observe it by using a cursor. I have clicked on A because here we can able to put 2 cursors. So cursor A I have selected. I will click on which point I need to get it. So it gives you what is the X value, what is the Y value. Same way I can select one more cursor here, and I can give you here another one. Both are in the same point, whatever the difference. But if you want to change another one like this, whatever the difference you are getting, X difference as well as a Y difference, both will be different. So that you can observe. Along with that, when you click on that that cursor itself, it will goes off. And along with that, here you have a one more option to do for each of the waveform. So for that, you can click on a legend button. This is your legend button, and that legend button you will be getting it. That button you can place it where you place it like this. It tells you blue signal will be a VG1 and lighter green will be a VR and this is VL. This will be your PC signal. So this also you can do it anyway if you are properly naming all the devices. So it will not be having any issues. Only thing whenever you want to put it these results in a report or somewhere, if you want to put a legend, that also you can do it. And whenever you want to see any one portion, that you can go here, zoom option and click on this. See, zooming also can be done and you can observe it clearly. So these are the things you can do it in the window and this is the result Sorry. So I want to go with the another example. Before going to the another example, I will show you here which are the examples they have already given from the software itself. Here you are having so many examples like a cap comparator, control loop, current measurement, tag, and filter designing, LDOs, and miscellaneous circuits and noise sources, oscillator, power amplifiers, precision noise. Along with it, here you can have a signal supply and all those examples they have given it. This also, when you click on this, you can get so many different versions of the circuit also you can get it and anything you can get it. For example, this is the example they have given it. You can observe here, they have given what is the name also and what will be the circuit and what is the description of the circuit also. So all those things you can do it. Experiments I have conducted here, some of the experiments. I think if we go through, it will be helpful for the faculty, those who are handling the basic electronics as well as AEC1 and AEC2 subjects also. And here taken one more example and that example gives you a very basics for the VLSI also. So let us go with the opening the circuits and I will see where I have stored the circuit. Let us initially take up the transistor characteristic. Why I am telling this? So if you want to get the graph also, how to get the graph also I will show you now. So let us choose transistor characteristic first. Open the circuit. Is it visible circuit? Is the circuit is visible? Circuit. Transistor characteristic I have taken in a common emitter characteristic. Whenever we want to do with see this, we know whenever we want to do an input characteristic, we know this will be kept constant and we will be varying. So see that when VCC is kept constant, I have conducted an experiment like this. 5 hours initially, other 2 hours participants, please mute yourself. VCC 5 volts I have fixed and you can start varying your value VPP from I think I have changed this value. Yeah. I click on this. Initially, I'll start with a 100 millisecond or a 0.1 volt. So again, go with the analysis. In the AC analysis table of AC results, you click it. So not only a 1 or 2 value, all the nodal values you will be getting here. Observe here. Actually, we know that whenever we want to find a input characteristic, we are drawing the characteristic as we change the VBB. We are drawing a characteristic VBE versus IB. So I require a value for the VBE as well as IB value. So I will observe in the table itself VBE value, how much you are having, and what is your IB value. So both the things you can note down. And here, actually, if VBE itself is varying, this is a dependent value. This value VBE is varying depending on the value of VBB. So therefore, parameter stepping cannot be done, or otherwise directly the transfer characteristic we cannot get it. So therefore, I am using here another one, that is an Excel sheet where I can draw the, where I can store all the values as well as I can get the graph. So I can show here, see for the VCC value 5 volts, PBE for here VBB also I have taken common values. For VBB 0.1 volt, VBE is also 0.1 volt, that you can observe here. VBB, yes, VBB is also 100 millivolt, and VBE is also 100 millivolt, and IB value. So IB is also noted, and I have taken it here. Similarly, I have done the experiment for all these values, for all like 0.1 volt to 1 volt, all these values I have noted what is the changeover that is happening in VBA as well as correspondingly IB value. So when we have noted all these things, we have observed that when it reaches VBB to a 0.6 to 0.7 volt or a 0.7 volt, it gets constant, or it is almost getting constant. So only the current IB is increasing, IB value only increasing, that you can observe it here in the graph. One thing you can observe here, only to see that what is the changeover we are getting for the VCC 2 volt, 5 volt and 20 volt. I have noted all these values and I have noted here. So when you click on this, so or whichever value when you click it, and that shows with respect to which value you have drawn that graph. So those things you can observe it. Again, here you can fix your VBB constant to get the output characteristic. In output characteristic, you are keeping VBB constant, but by choosing the VBB constant, we already know that we usually at which point we are almost keeping constant, that value we choose it. So I have taken two values when VBB will be a 0.625 volts and VBB fixed with 0.6 volt, and I have changed my VCC value from 0.1 volt to 0.6 volts, and I have drawn this graph. So you can draw the graph like this, but only thing that by changing all the values every time, whenever you are changing this again, 200 milli. So again you have to go with the analysis, DC analysis and the DC table. In the DC table anyway you will be getting all the values. You note down in the Excel sheet and then you can draw your graph. So this is regarding the transfer characteristic, and this is completely dealing with the DC value. We are not going with any waveform. If still if you want to see the waveform also, you can observe the waveform like DC analysis. Here you can go with the DC transfer characteristic and what is the start value, from which value of VBB you want to change, from which value of VBB you want to change, because here see that you have a variations, you can change any value and you can get the graph. So it is with respect to the VBB. So I have chosen VBB, and the start value will be a 0 volt, end value will be a 1.5 volt, and how many points you want to take, you can fix up the points and click on OK. This graph, actually from this graph you cannot identify it. Only thing you can see here, see, as initially it will be almost a constant, and it will be keep on increasing, and as the VBB value increases, initially the VBB value increases and it keeps constant. Only that analysis we can do it, but exactly how we require the response, that we will not be getting in this DC results transfer characteristic, because VB is an independent dependent variable. VBB we are changing with respect to the VBB, VBE is changing. So, but graph is required for VBE versus IB, so that we are not getting here. I think we can get it in a higher version by choosing which value versus which value we require it. But at present in the free version, we are not getting that. So this is the transfer characteristic we are doing it. And I'll take up one more example, opening the example, and here to show other parameters also. Yes, RC phase shift oscillator I'm taking. Yes, RC phase shift oscillator. Here, as I already told you that you can observe your output on this first set of RC value, second set of RC value, third set of RC value also. But before going for that, you can see first what is the result you will be getting it. See, go to a analysis, because we know that it is oscillator, no input, we will be getting only output signal for the oscillator. So go to analysis, and it will be a transient response. And one thing that as a engineers or as a teachers, we know that which response is considered as a AC response and a DC response as well as a transient response. So that's why anyway, we know that this will be a transient response. And here, as I already told you that I have designed this oscillator for generating a 1 kilohertz frequency. So therefore, my time period will be 1 millisecond. So I need to get at least 5 cycles. So I am taking with 5 milliseconds. And one more thing here, I am not finding any operating point. And I don't want to use any initial condition. With the 0 initial condition, I need to do it, and not required of any excitation. So therefore, I didn't check it. So I have chosen only the 0 initial value and click on OK. See this, you can observe. Initially, it takes some time to stabilize, and then it will start giving the 1 kilohertz frequency. So that you can observe it by putting a cursor from one value, and here see almost X value difference will be a 1 millisecond. So therefore, it is almost generating the 1 kilohertz frequency itself. But here from the one cycle, you will be getting an amplitude difference, because it is in an excitation. So therefore, and if you want to see the same thing in the device, any device like the oscillator, be careful when you switch on the oscillator. Observe the initial portion itself, because in the oscillator, whenever it is taking the excitation to reach up the required amplitude, till that it gives you the rising also, but only the initial point you can observe. That initial point you can observe. Then once it is stabilized, then you can get only the stabilized oscillations that you can observe it. Stop, again run. So initially you can observe it. Okay. This is the signal what we will be getting. Once you stop it, after stopping the signal, if you want to see in the regular window what we have seen in the previous phase, go to export curves, export. See, this is the oscillations we are getting, and this is obtained from the oscilloscope, so it will be given like this. And now you can give what will be the axis label and everything. And one more thing here, if you want to, while it is in a running, you can increase your time period, see, and you can also change the voltage level also, and you can change your position. Usually by default it will be under a 0 position. See, as I already told you, whenever you want to see so many outputs, then you can choose all these things. So this is the oscillator, what we are using it. I will show you how to use the function generator also by taking the another example. Open the example, and here I have taken rectifier I am taking. I have taken the precision rectifier. Yeah. See the circuit, and here you can change your input frequency also. So here, see, unit step it is there, but you change your to sinusoidal. Whatever the frequency you are having, let it be, but I will show you how to change it. And this is the thing, and as I already told you that in the precision rectifier, so both the devices are using same, so it is not necessarily you want to use different V plus and V minus, but here we have used, that's it. So run this circuit, but before running in the transient response, I will go with the devices itself. I am using the function generator. And I want to see the oscilloscope also, oscillator also. See here, if you want to change the frequency, click on the frequency here and go to edit. And then here you can change the value. And now the yes, 1 kilohertz I have made it, and amplitude if I want to change it, I will change it to a 2. Again click on the edit button, it will store here. If you want to change any offset value or anything, you can do all these things. And one more thing, Vin is the signal which is actually using this function generator. So all these things you can do it. Click on on. When you switch on, why I have taken this will be a sleeping one and the value is changing this. Why? Because see here, and you can off frequency when you are doing it. Here you can give the start value and you can give the stop value. I have given from 100 hertz to a 1 kilohertz. That's why it is changing its value continuously. If you don't want to change those values, go to your start value. And here again you give it 1 kilo itself. So now what will be the stop value and stop value is both will be the same. And then now you can give it as a on function. Once you on it, come to a virtual oscilloscope. Actually initially I want to get here, switch on, and we need to get here the output. Switch on and go to a oscillator. And here you are getting only V out. Why I will tell you once again. This is only the device, and see that running. So run the signal. So this rectified output you can see, and you can increase it or decrease the value. You can see this. But one thing that if you want to see the input signal as well as the output signal, for that close the signal and probe connect another probe where you want to see your signal. Connect your probe. This is in itself. Yes. If you want to see both the signal, now you can run and go to a oscilloscope once again. As I already told you, we have a V in as well as V out. So select a V in and click on run button and you will be getting this and take up the position and this position you keep it above. Why? Because it should not crash it. And now take up the another channel is also there. See, when you click on minus, you will be getting like this. Or otherwise, if you want both the things will be under same and you want to see in the coincidence value, both you can give it as 0 and V in also 0. So, En and this is amplitude, check it out. This is a 1. Yeah. See now, this is a coincident value what you are getting and whenever you want to get it, so this is the way how you can check it out, all these things. And here also if you want to see the cursor, stop here, select the cursor, run and select the cursor and you can click on wherever you want to. Or click on this and press on, see the cursors which is moving and wherever you want to hit it. See, all these things you can do it by stopping this. You can change your first cursor wherever you want to go and you can analyze it. And you can stop your function generator and this will be your precision rectifier by seeing the output even in the transient response also. So see, I think this you will not be getting because it is with a very simple, less value, the transient response, 5 milliseconds. We will take up with the 10 milliseconds. And I have not excited the signal. I think I have given you the unit step response. So that's why it is not coming. So in this way you can execute the things. And I want to show you one more example. I have taken a stable multivibrator also. Yes, a stable multivibrator also. So see that this is the waveform I am being integrated. I have connected two probes, one to check it out what is the output we are getting and what is the voltage across the capacitor. And we know that these are the three elements which are changing our T value, T on and T off values. So therefore here I am showing you another feature also. See that the transient response and click OK. See, this is initial rising will be like this and this is the way. And if you want to see number of cycles more with 10 milliseconds. Yeah. This is the way how you will be getting it. But we know that as I am changing the value of either a RB or a RA value, or by changing the C1 value, our T on and T off value will changes. So how you can observe that? So for that, in a single waveform itself, if you want to observe it, I will show you by using how to use another feature like a parameter stepping value. So I am clicking here the parameter stepping as I showed you in the PPT itself. So select the parameter stepping and which value you want to change it, click on that register, and here on this register, go to this three dot one, and now you will be getting this window, that is control object window, and here I will select, I need 5K value, and another one will be a 15K. But actually I have taken 10K and these values, and how many number of cases we wanted, I have chosen 3. So it is your wish from those values, how many values you want to get it. So that thing you can do it. Click OK. And now it is star symbol is there, and that symbol itself tells you that it is under stepping function, parameter stepping function. Now go to a transient response and again give it. See, and go to a separate curves. See, E out 1, E out 2, and E out 3. E out 1 is for the 5 kilo ohm, E out 2 will be the 10 kilo ohm, and E out 3 will be the 15 kilo ohm. As that is changed, our charging and discharging time period is also changing. So this is the way how you want to do the parameter stepping. If you don't want that parameter stepping, go to again a select control object and click on that resistor itself. Go to this 3 dots. In control object selection, remove the option and it will start will go. It means now it takes statically over 10 kilo ohms. And taking one more example. One more example, that is NAND gate using CMOS, or you can say it is a PMOS and NMOS circuits, PMOS and NMOS circuit. And one more thing here, this is not having any digital devices. The devices which we are available in the analog circuit display version, I have used this itself to show. One thing I have done is signal A and the signal B, both I am taking it as a square signal and I am checking the output also. So for that what I have done is square signal. One signal I have taken with a 500 Hertz. That time 2 milliseconds will be the time period, and another signal I have taken it with 1 kilohertz, that time 1 millisecond. So now you will be getting all the 4 combinations. And here you are checking the output. I have designed using the NMOS and the PMOS, the NAND gate circuit. We know that the NAND gate circuit, only when the values are 1 and 1, it is giving you the output as 0. Or otherwise it gives you output as 1. So that you can observe it by doing the transient response. Here again, what I have done is highest frequency which I have chosen, that have to be taken as a reference. Here the highest frequency that we have chosen, the input signal is 1 kilohertz. So at least if I want to get it 10 cycles, then I need to choose 10 milliseconds. I have taken that one. Click OK. See, like this you will be getting it. So go to a view and the separate curves. You can observe here 1 and 1, 1, 1 you are getting 0, and 1, 0 you are getting 1, and 0, 1 you are getting 1, and 0, 0 you are getting 1. Actually we don't have any such devices. So therefore I have used, this is a method to conduct the digital experiment itself. And along with that, we will also get an idea how to rig up any circuit as a basic circuits in the CMOS VLSI also. So this is the way how anyway NAND gate how it is working. So like this we can do it. Along with that, I have done one more function, that is pulse width modulation. So that also you can do it here. Pulse width modulation. So you can observe the waveform, transient response. See, this is the pulse width modulation. As the increase in the modulating signal increases, and the stereo signal is also changing. This is the way how you can do it. It is your wish. But here, when you go with the spice macros, you can identify so many devices. And along with that, we are also conducting one more example. Digital to analog circuit is also done. ADC, I have done it. But here I have used a switch, and I can observe this by using a DC analysis. All the calculations it will do. Now it will give you the output. Say observe the output. So whenever, it is switch open, it is indicating that the open circuit is connected. Wherever it is given, but actually it is indirectly connected with ground. So therefore 0 volts. Finally, VF1 is the final output, that is 1.56 volts what we are getting from the digital to analog. In this way, you can do any number of experiments, and you can conduct any experiment. I think I have covered all the examples whichever I have done it. Even the low pass filter also, as I told you in the slide itself. Here, parameter stepping can be done with it. Here I didn't show you this AC analysis, AC transfer characteristic when you do it. Click OK. See, this is the way how you will be getting the gain plot and the phase plot. And 3 dB down, when you want to see that, click on this cursor and somewhere replace it, X value, I think, or Y value. Y value, you can change your 0, 0, yeah, exactly. And now it is showing what is the X value. I think here, yes, X value. Actually, this is the line which is indicating 20 kilohertz, almost it is 20K itself. So that is the 20 kilohertz, it is having a cutoff frequency. The low pass filter which is designed is also a 20 kilohertz second order low pass filter. So that itself we are getting it. And along with that, if you want to see any Fourier analysis, go to a Fourier series. See here, as I showed you, you have a cosine function, or otherwise you can go to a trigonometric evaluation series, Fourier series, or a exponential Fourier series, anything you can take it. And if you want a 16 harmonics, or if you want a 8 harmonics, anything you can choose it. And 8 harmonics I will conduct and calculate it. See all the values, what is the amplitude you are getting, what is the phase you are getting, all these things you can observe. All these values you can observe and you can get it. And same way, go to a cosine values and calculate it. So again, with respect to a cosine function, you will be getting a different. And with respect to a trigonometric evaluation, you will be different. So these are the values what you will be getting at A and B, all those things you can observe. And you can also do the noise analysis by giving any noise signal and those things. And if you want to find out any signal, like a signal analyzer, go to a signal analyzer. Here again you have so many signals, swept sign and amplitude spectrum, or a swept sign, anything you want to start with it, you can start any signal and you can do the output. See? But here, see, can you observe the gain plot? Next sign. This signal analysis you can do. Amplitude spectrum also you can do. How the changeover that is happening. So these are the things you can do. So I think I have covered all these things. So close it. We have finished all the, actually I have tried to complete so many experiments which is available in the free version. But I want to show you which are the additional versions is also there in TINA TI. That is here. See, we have a basic digital circuit you can see here, and apart from that, you can also do the basic digital circuits like a counters and all those things you can do it. And apart from that, microcontroller circuits also you can do. With that, additional HDL simulators can also be done it. All these things. And here you can also get the HDL, that is the programming, HDL program also you will be getting it. And all the additional features you can observe here will be a model development. And the SPICE simulation is also there. ADC and DAC simulation is there. Verilog and systems support is also there in the additional feature. And the circuit design with optimization can also be done it. And integrated PCB design is also done. And lab explorer and lab, TINA lab to multifunction PC instrument is also present in this.
Madam, thank you.
Thank you, sir. I think, yeah.
Madam, there are a few questions in the chat box. Can you just...
Yes, sir, I am seeing it actually. Yeah, Nilga sir, here actually at present in the free version, we will not identify much of the advantages. But compared to a multi-sim, here we are having so many features in the licensed version. But just at present, we are handling in the college to do the basic electronics lab. And with this version, we could able to manage it. But when we are going for the project development and all, with this version, we cannot, we can't do it. But yes, from the licensed version with the advanced technology, so many parameters are there in the TINA TI, even in the PCB designing, layer to layer, and whatever we are identifying the problems, everything we could able to rectify it and we can design it. Till the product level, we can guide our students if we are using the licensed version of TINA TI. So, is anybody having any doubt?
Madam, there are some more questions on. You can just scroll up and see.
Sir, actually, question is not there. Yeah, it is a open source, but it is a free version. It is a limited version.
There is one question. Can I read it out?
Yeah, yes, sir.
We use MATLAB and LabVIEW for circuits. So how it is different with other softwares?
Sir, actually, MATLAB also we are doing it, sir. But few devices, it will be a simple to do here. It is even for the first year students itself, they are enjoying, and it is a very simple. And when we go with the all digital circuits to see all the experiments and everything, will be easy actually. Main advantage they are telling for the Tina compared to MATLAB is it is a free and it is very accessible, and even we download and we can also download it and we can try to do it all these experiments. But these are the experiments I just tried it out. So like this, you can go with the higher version also, because anyway till the 100 to 200 nodes it will be supporting even in the free version also. So that's why I felt this will be little bit easier compared to MRT.
There is one more question that for this software, can we connect any hardware to live data controlling?
No, it is actually called as a simulation software itself. I think if we go with the higher version, maybe we can do it, but even I don't know completely about the licensed software. But they have done so many experiments also on this, and they have done because it is connected. Why? Because they are using so many live signals itself. As I told you, like wave signal that can be downloaded and we can give it. Any real-time signals also can be given and we can simulate it. It is a simulation software.
Okay. Thank you, madam. I think there is no other this thing in the chat box, the questions. We will conclude this
I
session.
think one more question it is asked, maximum data size for the wave file. I think 3 to like till 20 KB.
Okay.
Yeah. Usually it will be 3 to 4 KB. I have seen some bird sounds and all. So that many files, those files I can.
Hello, sir.
Hello, sir. Good afternoon, sir. Madam, I think we will conclude this session.
Thank you, sir. Yes, thank you for the opportunity.
Yes,
Thank you, madam. It was a very good hands-on session. Very nice demo you have given it to all the participants. The participants are very happy. I think many of them were not aware of this.
Sure. You need some staff, no? I will. Yeah.
Okay.
Definitely, sir. 100%. Done.
Yeah. Sir, we will have a small valedictory with this session.
Sir, Prashant, sir.
Yeah.
Sir, can you share this PPT? It's very informative.
Yeah. Madam will share with me. I'll share with all the participants. Nothing to worry. Okay?
Thank you, madam. Thank you.
Yeah. Vaibhav sir, please address the participants, and after your address, I will conclude with summarizing the webinar series and propose vote of thanks. Sir.
Okay, sir. Sure. Good afternoon, all the participants. I hope you had good learning sessions in last 2-3 days. We had put our extreme efforts to see that there are no much technical glitches. We had put our effort to see that you are understanding all the lectures. Am I audible, Prashant sir?
Yes, sir. Yes, sir. You are right.
Yeah. So we had seen from our side, we had put the utmost effort to see that there are less technical glitches. 1 or 2 here and there, it might have happened, but we are sorry for that. But I hope that you had learned a lot of things here. It is not that we are finishing up with this thing, but I think you should use all this knowledge that you had gained during last 2-3 days to build your projects, to build your interdisciplinary skills, and this was basically to enhance our interdisciplinary skill set, so that now the era that what is coming up is related to the interdisciplinary only. So you can interact with other departments also. You are aware of whatever we had here. We had tried to give a overall idea about the software used and what you can do with the help of the software. So if you had attended all the first of its kinds webinar series where we had seen
it was interdisciplinary. So the coming era is what I'm trying to emphasize here. The coming era is related to the interdisciplinary. We have to work with other teams, not only with our teams, with other teams, other discipline team to see that we are coming with a good solution. And we will try to see that with this type of the knowledge, we will try to see we are addressing the societal problem related to our nearby our society. What are the problem we are facing? Try to apply this knowledge there. And I thank our management, our VC sir, our Dean sir, specifically all the speakers, and above all, Dr. Prashant, who had taken extra efforts, to, who had gone out of way to arranging the people, and it's a very tough task you might be doing in this type of situation, and people had obliged it, our request. I thank all the participants. I thank all the speakers, those who had given their time for this activity. Actually, it is a sort of a social activity only, because knowledge sharing, it is sort of a knowledge sharing, which is basically a social type of activity. And I thank all the speakers. Once again, I thank all the speakers, those who had put their efforts in making us, those who had to put the efforts to see that this is going through well. I thank Dr. Prashant also once again, and all the speakers. I hope all the participants had understood all the session. We will try to see that there were some concerns related to slides and all. We'll try to see that slides are shared with you. You be in touch with Dr. Prashant, and he will see that all the slides, whatever the material was there, it's shared with you. With this, I am saying all the best to all the participants, and you got overall little bit, not overall, but a little bit knowledge about the tools that have been used, which is very much essential. Thank you once again, and have a nice day. And stay home, stay safe, and be happy. Don't get panicked in this type of a situation. Try to support each other. We are going through a very rough phase. Nobody had seen this phase in their lifetime. A living person had not seen this type of a phase there in lifetime. So be calm, be quiet, don't take tension, support each other, and with all the support, we will grow together. Thank you very much.
Thank you, Vaibhav sir. Thank you. Sir, your friend Nilgar sir is there, and he's...
Nilgar sir, you would like to share your feedback, sir? Please, if you are our senior person, you have guided us. Nilgar sir?
Nilgar sir?
Bacharaj sir? Nilgar sir? Can you hear us?
Sir, unmute yourself and...
unmute yourself, sir. And we will take some feedback from the participants also, sir. How are the session? Because they are the real people.
Can you hear me now, Vaibhav?
Yes, sir. Good morning. Good afternoon, sir. Thank you, sir. You had attended the session. Your blessings were always with us. Thank you, sir.
In fact, the day I saw this one, I got a mail, no? I registered, but I am surprised to see that I could make all the sessions almost.
Great, sir. Thank you, sir. It's all our efforts from Mansa madam and our.
I was too busy, but I could make it. I don't know how I could make it.
And Prashant sir and all. Thank you, sir.
And Prashant, I think he's from Belgium, right?
Yes, sir.
Yeah, he's your friend only, sir. He's your friend.
I don't remember him. I hope he knows me very well.
Yes, sir. I know you very well. We have met, sir, in DSU itself.
Yeah, I am the
You had come for the exam?
See, I am the person to create all the initial platform in DSU. I hope you know very well.
Correct.
I hope it was helpful to all people.
Yes.
Yeah.
Thank you, sir.
Because of only distance, I could not make it out. Anyhow, Prashant, it was very good. In fact, I was surprised to see how you could get all these people from all the corners of India to give the sessions. Really good. Maybe next time I may take your help for such things if required.
Definitely, sir. I'll be there, sir.
Sir, one more hour, sir. Nilgar sir, one more hour FDP is there on photonics and all these things. That also try to attend, sir. It will also informative. We have people from industry as well as from IIT Kharagpur.
एक दिन 2 दिन कर सकते हैं, 6 दिन करने का मेरे को वो भी full day.
No, it's not full day. It's 2 hours.
We'll have full day 2 hours. तो काम करने का तुमको सुनना हम लोग है.
Sir, we will conclude, sir.
Yes, sir.
Yeah,
Thank you.
thank you, sir. Any other speaker is there who wanted to give his valuable feedback on the session?
Any participant would like to give a feedback?
Any participant? Your feedback will always be helpful for us to improve us and to see how best we can support you in future in this type of a webinar series.
Anybody would like to give? Otherwise, we will conclude, sir. Participants.
Okay, thank you, sir. Yeah.
Okay. Sir, I think nobody is there. I'll just conclude it, sir, with summarizing and proposing the thanks to all the members. It gives me immense pleasure to propose my gratitude to all who were a part of this 1 week webinar. This was one platform which brought all the disciplines, resource persons, faculty members, and students, friends together to share their knowledge and experience on the use of simulation tools. I deem it privilege to thank all the resource person who accepted our invitation and shared their knowledge with the participants. Behind every event, there are people who are the pillars to us in encouraging us to move forward. At the outset, I would like to thank the Vice Chancellor, Professor KNB Murthy, the Registrar Putmadappa sir, Dean A. Srinivas, and Chairman of Electronics and Communication Engineering, Dr. Vaibhav Mishram, for all the support extended to me in organizing this 1 week mega event with a total of 18 sessions and 18 resource persons and 18 different programming and simulation tools to learn, explore, and take it forward in our research or academics. This webinar would have been a failure if we had no participants registering. We had an overwhelming response of 600 plus registration totally and around 80 plus participants participating in each session with the choice of their field and discipline. A heartfelt thank to all the participants for being very interactive in all the sessions. Last but not the least, I would like to thank each one of them who have helped me directly or indirectly in successfully organizing this webinar smoothly. I would also like to thank the Cisco WebEx for giving us the platform for the meeting, and also the YouTube for transmitting all the webinar series on live. Thank you one and all. Good day. The three video sessions video will be shared with you once the resource person will share with us the on the cadence, then the mentor graphics, and the CATIA. Apart from that, all the session materials will be shared through Telegram, and by evening we will be sharing the e-certificate link also. Please be with the Telegram group till 5th of July. By the time we will consolidate everything along with the video links, we will be sharing all the materials. Thank you one and all for the wonderful being a wonderful participant in the webinar series from 22nd to 27th June 2020. Thank you one and all. I have shared the session feedback link. Please fill that session feedback link, and in another 10 minutes time we will end the meeting. Thank you.